Hello, people. Lever here from Bright Young Brains. In this 2014 November paper 2, grade 12 memo, we're going to go through all the questions from start to finish without leaving anything out. And this is a CAPS paper, Department of Basic Education. Now, the big idea is obviously the deeper explanations of anything that you may not understand, you can always get that on our website on the online courses. And if you would want to ask something specific, you can always just hit me up on IG. Without wasting any time, let us dive into question number 1. Okay, so question number 1 says, at a certain school, only 12 candidates take mathematics and accounting. So this is trying to give you the idea that obviously they mean that people that take accounting together with mathematics, you have a total of 12. Okay, I think that's a bit straightforward. And then they said here that the marks as a percentage scored by these candidates in the preparatory exams. This is like prelims. In the prelims, for mathematics and accounting are shown in the table and scatter plot below. So here, as we can see, they have the marks for mathematics. We can see that, okay, marks for mathematics, marks for accounting. Before looking at the scatter plot, I mean, we can maybe almost see that the marks are somewhat close to each other, like, here, close to each other. There isn't a big gap between the accounting mark and the maths mark. And the scatter plot kind of shows that, because here it's saying percentage achieved in mathematics. We can see that as the percentage in mathematics increases, the percentage in accounting also increases. And then it says for 2 marks here, calculate the mean percentage of the mathematics data. So whenever you get questions like these, right, what you want to do is you want to put your data into your calculator. So when you're going to put your data into your calculator, you need to be very careful. You see, you need to be careful because putting this data into your calculator, you have to do it bit by bit, step by step, so that you don't make an error. So let's see what we can do here to put this data into our calculator. So putting this data into a calculator, you'll have to press what you may call the following button. So you have to say shift mode, you have to say mode and then stat and then number 2. So you have to click mode on your calculator, and then you have to press stat, and then you have to press option number 2, which says a plus bx. This is the equation of the least squares regression line, and then 2 columns are gonna pop out. Obviously in these columns you need to what is this, you need to put in values for x. So values for x, you're gonna make that the maths values, and then values for y, you can make those the accounting values, also because of the scatter plot. You see x-axis, y-axis, and then so let's put in this data into a calculator bit by bit. Now the one thing I can safely say is, in questions like these, right, you normally may find yourself losing marks, maybe because the data that you put into your calculator, you made an error. So obviously you should maybe not be like paranoid such that you spend 10 minutes like just checking if you put in the data in your calculator correctly. But I think just, some seconds just looking over your data and trying to see if you wrote down all the numbers properly, it goes a long way in terms of, just you being confident in the answers that you're going to be getting once your data is put in the calculator. So normally what I do is I put in all the x values first, so one column, I put in all the x values first, and then after putting all the x values, I go back to the top, and then I start putting all the y values, which is what I'm doing now, and we are done. So all the values in the data, So you're gonna populate your table. I'm gonna put in values there, going on and on and on. This is a table or whatever you want to call it. You're just gonna add values in there, and then you're gonna press the on button, and then now you can press shift and then the number 1 button. You can press shift and then you press the number 1 button in your Casio calculator, and then what? And then you're gonna have to press number 5, which says reg. There we go. So in this situation, they said we should calculate. Wait, we need the mean data, so we actually don't need to. We don't have to press reg per se. We can press var because here we need the mean. Reg would be if we needed maybe like the equation of the least squares regression line and we needed A, B. So here we can just press shift and then the number 1 button, and then we press var. You see, after you press var, you're going to see that there's X bar here. There's option 2. You're gonna click that, and then you're gonna press equal to, and then our answer here is gonna be 68. So that's the average for the maths. If they had said average for the accounting, you would do the same thing, but then you would choose Y with this on top of it. So that's 1.1, nothing too difficult there, or nothing difficult at all. Rather, moving on, let's see what we have. It says you calculate the standard deviation of the mathematics data. So calculating the standard deviation for the mathematics data, we are practically going to do the same thing. You see, we're going to, in our calculator, we are going to press shift. In our calculator, we're going to press shift, and then the number 1 button. And then, just like what we did previously, right, you are also going to press var. And then after you press var, you're going to choose option 6, the one that has something that looks like, no, bro. Option 3 is the one that has standard deviation for X. So option 3, you're going to choose that one. It has something squiggly like this. And then once you choose that, you're gonna press the equal to sign. And then after you press equal to, it's gonna give you, what is it giving us here? It's giving us 18.42. So remember, standard deviation gives you an idea of how far on average each piece of data is away from the mean. So you can imagine deeper explanations on all this kind of work. You can always sign up for things like the statistics course on the website. It's literally just like 99 bucks per month, and obviously it's not a contract or anything like that. You can always cancel at any point in time. It's literally just R99 per month. You know, if you sign up for like a single course, that's, for example, if you're going to start with like the statistics course. If you start with the statistics course and you just want to sign up for the statistics course, you'll see it's just 99 bucks a month, and you can cancel whenever you're done with it. It says you determine the number of candidates whose percentages in mathematics lie within one standard deviation from the mean. So questions like these, they shouldn't like trouble you. You need to know how to answer these kinds of questions. Like, they should be your cup of tea because they are just that simple. So with what we have just said now, right? If you're going to work out the number of candidates whose percentage in mathematics lie within one standard deviation from the mean, what you do is you take your mean, right? You subtract your standard deviation, you get a number. And then you also take your mean, right? You add standard deviation, you also get a different number. So once you have these two numbers, right, you will need to find out how many marks are within that range. So for example, our mean, we found it to be 68, right? So the mean is 68. So you're gonna have 68 minus the standard deviation, which is So they said within 1 standard deviation. So because they said 1 standard deviation, we will need to just minus the standard deviation once, you see. So this is like 18.42. And then here, this is just to split up the two numbers. Here, we're going to take the mean and then you add the standard deviation once. So let's see what this gives us in the calculator. 68 plus 18.42. Let's see. That one is giving us 86.42. That's the one that goes here. And then the one on the left here, we have 68 minus 18.42. This one is giving us 49.58, right? There we go. So all you now do is you need to check which numbers are within this range. So starting, a number has to be bigger than this one, and it has to be smaller than that one. All those numbers, we have to count how many they are. So we need numbers here that are at least bigger than 49 point something and smaller than 86.42. So numbers, we have 1, 2, this don't qualify, this qualifies, this does, this does, this does not, this qualifies. No, that does not qualify, it's too small. It doesn't qualify, it's too small. This also qualifies. Let's just double check. You see, it has to be bigger than 49.58 and it has to be smaller than 86. So this is bigger than that value. This qualifies. No, it's too big. No, it's too small. Yeah. So we have 1, 2, 3, 4, 5, 6 numbers that are within 1 standard deviation. So we say 6. Determine the number of candidates. So that's 6 candidates. If they had said determine the number of candidates whose percentage in mathematics lie within 2 standard deviations from the mean. If they say 2 standard deviations from the mean, what you do is you put a 2 here, you put a 2 there. And then here you would just have multiplied your standard deviation by 2. Here you would have just multiplied your standard deviation by 2. And then you would have different numbers to work with, but you would still just do the same thing, you see. So you can imagine exam papers, they have, you know, certain questions that they ask, but then things like online courses, they give you different variations that they can ask the same question. So hence why I always suggest you do sign yourself up. But anyways, let's move on to the next question, which is 1.4. 1.4 says, calculate an equation for the least squares regression line for the data. So the equation of the least squares regression line on your calculator, this is what it looks like, you see, or on your formula sheet rather. And for you to get that value, the fortunate thing is that all you need to do is you can just use your calculator. You see, least squares regression line. So you're gonna press Shift and then the number 1 button. Let's write it out. You're gonna press Shift. Yeah. So let's fix that here. We're gonna press Shift, the number 1 button, and then you're going to press number 5, which is reg. Now you press reg. So after you press reg, obviously you're going to see that there is an option to choose. There's A and B. So you just choose them one at a time, you see. So you're gonna choose A here, and then you say equal to, and then you're gonna get, let's see what our A value is. Here we're getting, let me just say here, you choose A, you press equal to. Ooh, somebody's hungry. Yeah, it's in the morning. We'll just drink some coffee until further notice. Anyways, so once our value of A here is 22.82. Is it 22.82? There we go. And then you do the same again, you see. So if you do the same thing again, let me just put like ellipses here. If you do the same thing again, right, you're gonna press shift number 1, rag, and then you choose B. You see, this is gonna give you 0.66, 0.66. So here you're gonna say, therefore, y is equal to 22.82 plus 0.66 x. There you go. So without wasting any time, let's keep moving forward. If a candidate from the group scored 60% in maths in the maths examination, but was absent from the accounting examination, predict the percentage that this candidate would have scored in the accounting examination using the equation in question 1.4. Round your answer off to the nearest integer. So this is important because out of 2 marks, you might end up getting 1 just because you didn't round off. So when you need to predict, right, this is where you calculate when you need to predict a mark, this is where your equation comes in, because if they said the maths mark is 60, all you do is where x is, you're gonna put 60, and so for y, you see 22.82, 0.66, you're gonna put 60 here, and then let's just put this in our calculator. So obviously you can see that the stats section of your work, this is definitely super easy, and there's really no excuse to not get these marks, like all of them. So this is to 2 decimal places, but then to 1 decimal place, it's gonna be 62. It is 62%. So that's gonna give you 2 marks, and you keep moving forward, you see, because question number 1 and 2, which is stats, you're just gonna bank yourself some time. So let's move on. 1.6 says use the scatter plot to identify any outliers in the data. So I mean, it's a 1 mark question, and yeah, I would say this looks like an outlier, right? Yeah, this looks like an outlier, but the fortunate thing is there's a way to calculate if something is an outlier. So for example, here, this is like 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th piece of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hypo. 1. Which one is this one now? 80 something. Oh, no, it is not in order. This is like 80 something for maths, but 60 something for accounting. Where is the piece of data? There, it's this one. Let's see if this is an outlier. This would be an outlier if your, well, I mean, yeah, let's see. Is there a standard deviation for the 2 sets of data? Yeah, I think in this situation, because we're dealing with a scatter plot that has like 2 sets of information that is considered. Your outlier, you can basically see it visually. Like you see this one that we pointed out, it's a bit falling out of the trend. So we'll choose that as an outlier. If we're gonna give an answer, use the scatter plot to identify an outlier. They just meant like on the image, we should, circle it and all that, but we can just write out 82 and 62. So you can do that by maybe even writing it almost like a coordinate. You see 82, 62, 82, 62. Oh, that's a coincidence. But anyways, let's move on to question number 3. Question number 2. Question number 2 says the speeds of 55 cars passing through a certain the speeds of 55 cars passing through a certain road, passing through a certain section, right, of a road are monitored for 1 hour. The speed limit on this section is 60 kilometers per hour. A histogram to present a histogram is drawn to represent this data. Okay, not bad at all. Let's keep things moving. Let's see what they want us to do. They said here the histogram, okay, histogram, obviously the interpretation, we know that all it means is speed. The cars that were driving between 30 and 20 is just one car. The majority of the cars were driving between 50 and 60 kilometers, and then cars that were exceeding the speed limit, less and less and less. And then, as you can see, that cars that were way over the speed limit, there's quite a few. Here's just two, and here's just one. And in total, if you add up all these numbers, they add up to 55 because there are 55 cars. And again, let's see, one mark says identify the model class of the data. So model class is going to be the portion of the data that appears the most, you see, where you have the most data. So it's between 50 and 60. So here you can say something like between, you can say 50 to 60. But the thing is, you have to write your answer mathematically, you see. So if you're going to write it mathematically, you will have to say that X, right, is bigger or equal to 50, but smaller than 60. You see, that's how you do it, because the next one, if it was 70, if it was 60 to 70, you'd have said X is bigger or equal to 60, but smaller than 70. So that's just remember that that's how it works. The inequality symbol here is the one where you have smaller or equal to. The one here is where you have smaller or this one is when you have bigger than or equal to, and then this one where you have smaller than, because this is saying that your data is between 60 and 50. Or you can say between 50 and 60, same idea. Moving on, 2.2 says use the histogram to complete the cumulative frequency column in the table on the diagram sheet. So anyways, the cumulative frequency table, right, always needs the different classes for you to be able to properly insert your data. So we have quite a few classes that we were given. So obviously on your side, you do have the table nicely, printed out and all that. But on my side, seems like somebody forgot to put it. But anyways, it's like 1, 2, 3, 4, 5, 6, 7, 8 classes, right? So 1, 2, 3, 4, 5, 6, 7. Well, could just do this, make it smaller, create more space. We need 8, right? So let's see here, 7, and then let's just do 8 one here. So here we're gonna have the different classes. Here you're gonna have the cumulative frequency here, cumulative frequency. There we go. So the different classes, well, I think I'm just, obviously here your data would have been filled in nicely already. The different classes, it's 20 to 30, going on and on and on. So let's see here, 20 to 30, 30 to 40, 40 to 50, 60 to 70, 70 to 80, 80 to 90, 90 to 100. There you go. And it's just saying X is between each of those values. So let's see here. Yeah. So fortunately, I mean, don't mind me redrawing all this, because on your side, you'll have this drawn out for you. So all you have to do now is, if you're going to have a cumulative frequency table, I actually need to add an extra column here. Yeah, I need to add an extra column. Because for you to properly draw your frequency, your cumulative frequency data, you need to have the frequency. You see, because cumulative frequency refers to each piece of data once it has been, added up to the previous one. So before that, we do need like a column in the middle, just to make life a bit easier. And I think also in this video, as us like drawing everything and all this, it helps to also better break down the logic behind, the cumulative frequency. So here you'll have frequency, and frequency is going to be these numbers here. You see 1, 7, 13, 17. So let's put that data in our table. 1, 7, 13, 17, 9, 13, 17, 9, 5, 2, 1, 5, 2, and oh no, what happened? I think I made a mistake here because it's 50 and then goes to 60 immediately. Forgot one of them here. Yeah, this is 50, goes to 60. There we go, not a problem. So that's fixable. So yeah, always be anticipating any funny errors when you're going to do your maths so that you can always double check your work. Whew. Coffee. Yeah, coffee is like a miracle, yo. Anyways, let's see. Moving on to, yeah, so with your cumulative frequency table, when you're starting off, you only have one piece of data, so you just have one, and then you just keep adding to it, you see. So this one here, you plus the 7, you have 8. And then you plus the 13, you're going to get 21. And just use your calculator, don't be a hero. 21 plus 17, you're going to have 38. And then plus 9, you're going to get 47. Plus 5, you're going to get 52. And then plus 2, you're going to get 54. Plus 1, you're going to get 55. Else you should. Because if you don't get 55 down here, it means there's something wrong. You see, so for you to somewhat for you to check that what you did is correct, you should get 55 here. It says here, so that's all we had to do for 2 marks. Wow, sounds rough, but it is what it is, Draw an archive, which is a cumulative frequency graph of the above data on the grid. Okay, so I mean a cumulative frequency graph, it's an easy graph to draw, so you don't have to stress too much about it. As a matter of fact, let me actually try and maybe use this as like a mini template. I'm talking about the scale, because you see our cumulative frequency is going to have the 20, 30, 40, 50 up until the 100, right? And then the y-axis is just going to be a bit different. It's going to have it needs to at least go up until what you may call 55. But let's just show it here. So we have our cumulative frequency graph here. So this is your cumulative frequency. Actually, let's just start at least at 0. You see, so 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we have to go one more, which is going to give us our 100. There we go. Everybody is happy. Okay, so this being done, we have just drawn our x-axis, right? So the x-axis, you always have the class here, the different classes. You see, you can just say class, and then here you have to have the cumulative frequency data. Like for example, you can see your data has to go up to 55. So here seems like you can go in. Let's firstly go in tens, and then we can half it. So you can say here 10, 20, 30, 40, 50, and then in between that we can like 5, 5, 5, 5, and 5. So here you see we have we said we're gonna have 10, 20, 30, 40, 50. Serious? Really? How did that happen? 10, 20, 30, 40, 50. Seems like, hey, we can have space. Let's just extend it. Fortunately, on your side, you see everything would have been given, so you won't have to worry about, the scale and all that. So 50 and then 55 would be roughly in the middle there, which is okay. So what you're going to do is when you plot your data, right? You need to be careful, because what happens is, firstly, you always need to plot your data somewhat in line with the specific number here. You see, so for 20 and 30, right, you're gonna plot a 1. So here, that's gonna basically look like this, you see. And then between 30 and 40, you're gonna plot where 8 is. So meaning you plotted 30, 8 is before 10, you see. So you do that. And then here you have to plot 21 at 40. Let's see here, there's like something over there. Going on and on and on. Let's see here. For 50, we have to plot 38. So 50, 38 is like somewhere over just after, it's before 40, yeah. And then for 60, we have to plot 47. So for 60, we plot 47. That's before the 50 there. And then for the 70, we have to plot 52. 70, we have to plot 52, which is just after 50. 54, we have to plot 80, we have to plot at 54, which is before 55. And then at 90, we have to plot 55. Let's see there, which is gonna be somewhere there. Your archive, it always has to be grounded. So you're gonna don't draw it with a ruler. Don't ever connect this data with a ruler. So it's gonna go like that. There we go. It has to always go to the ground. There we go. You see. So there's your data. It looks okay. But the 30, I think the 30 is a bit of an issue. 30 is what? 30 is at 7. Yeah. 30 is at no, 30 is supposed to be at 8. Yeah, which is fine. Nothing, but did I? No. Wait a minute. Yeah, with our archive, let's see here. Because, yeah, supposed to plot what you may call. Yeah, I think I just need to move this 1 to the right, because with my archive, I need to move this. Yeah, I just remembered I was using the 20s and we're supposed to use these values like 30, 40 going onwards. So all I need to do is to move this just 1 to the right. This whole thing here, it would just be starting there. Okay, there we go. And then this is what our archive would look like, you see, because your archive, you'll be using, let me actually just circle it. You're going to be using this piece of data. This would be like your X. This would be on the X-axis. And then this here would be on the Y-axis. So let me just draw this a bit better. There we go. There we go. Let's see. So that's that for this archive. Let us move on to question 2.3. 2.3 says, the traffic department sends speeding fines to all motorists whose speed exceeds 66 kilometers per hour. Estimate the number of motorists who received a speeding fine. Oh, so exceed 66. So it means that if you're gonna, so the idea is, right, firstly, 66 would be between 60 and 70. So what we know is that this is how you can do it. You can use a table or the histogram. So between 60 and 70, this is where 66 is gonna be, right? So if you're gonna use your cumulative frequency graph to make that estimate, what you're gonna need to do is you need to go where 66 would likely be. So 66 would be like somewhere there, right? And then what you do is you would trace your value to your archive, and then you would trace it to the cumulative frequency section. So here we have the class on the x-axis, and then here we can say CF, cumulative frequency. So here we would have had, if you take this up, going up here, you are going to see that you are most likely going to land somewhere before 45. You're going to land somewhere around 45 actually. Yeah, just before or somewhere there. So around 45, let's just maybe make it like 44 there, somewhere there is where you're going to land up. Remember, so here this is around 44, you see. So what you know is the number of people, it's going to be, so up here we have a total of 55 people, but from the 44th person up until the 55th person, those are the people that exceeded 66 kilometers. So here you're gonna say 55 minus 44 equals 11 people. You see, approximately. Let me put here approximately. You see, approximately 11 people, but the question had said, estimate the number of motorists who will get a fine. Let's see here. Yeah, it's around 11 motorists, 11 or so. So let's move on to the next question. Question number 3. Question number 3 says, in the diagram below, a circle with center M, so this is the center, touches the y-axis at N and intersects the x-axis at A and B. And then it says here that P, BL, and SKL are tangents to the circle, where SKL is parallel to the x-axis, and PS are points on the y-axis. So this sketch looks very interesting. Fortunately, if you think of your tangent laws, you already know that these are equal because tangents from the same points are equal. Furthermore, just adding more information into this sketch, we know that a tangent is always perpendicular to a radius. So these pieces of information, yeah, I think they're going to be useful to us at some point in time. And then let's see what's the first thing that's being asked. It's a 1-mark question. Write down the length of the radius of the circle. So the length of the radius, okay, yeah, so this is where you have to use a bit of logic, you see, because from here up until there, this is a straight line, a straight horizontal line. And if this y value is a 5, it means that the distance here is a 5 because the circle is touching the y-axis. So here, radius is equal to 5. 3.2 says write down the equation of the circle having center M in this format. So we have the center and the radius, so this shouldn't be difficult. Whenever a circle is not necessarily at the origin, we know that this is the formula that we can use, right? Yeah, so let's see, x value of the center is like 5, and then y value is like 4. So here we have to put x minus the 5 squared, y minus the 4 squared, and then the radius is a 5. So you can see why they made this a 1-mark question, because it's just a matter of plugging in information into the formula. 3.3 says write down the coordinates of A. Where's A? So A is one of the x-intercepts of your circle. So getting an x-intercept, you have to make y a 0, you see. So in this situation, let's see here, A. So you have to make y a 0 in the equation of your circle, you see. So let's see. This is the equation. This is the equation of our circle. Paste it, and then we have here, we want to make y a 0, right? So let's just make y a 0. If this is a 0, it's going to be 0 minus 4, which is minus 4, And then let's just solve for x here. This is going to be x squared minus 10x plus 25 if you FOIL out the brackets. And then negative 4 squared is a 16. Let's just bring the 25 over to the other side. And then, fortunately here, you see this is going to cancel that. You have x squared minus 10x plus 16. Factors of 16 that give you 8, it's going to be 8 and 2. I mean, factors of 16 that give you 10, it's 8 and 2. To get a minus 10, it has to be... nope, this don't work. Because 8 and 2 do give... Oh, yeah, minus 8 and minus 2 will work. Minus 8 and minus 2. That'll give you a minus 10, right? So x here is equal to 8, or x here is equal to 2. And then it says here, if the coordinates of B are this, calculate the gradient MB. Wait, the coordinates of what is given? Let's see, they gave us the coordinates of B, 8 coordinates 0. Wait. Here, oh yeah, of course, we are not done here. The coordinates of A, we have the x value. X is 8, y is a 0. No. X is the first one. So here we were not done. I would have actually just gotten 2 marks. But here they gave us the coordinates of B. Calculate the gradient of MB. Not a difficult question because we're just going to use the gradient formula. We're going to have here 0 minus 4, 8 minus 5. You see 0 minus 4 and then 8 minus 5. 0 minus 4, 8 minus 5. This is like minus 4. 8 minus 5 is 3. There's your gradient. So if you wanted to maybe write out the gradient formula, y2 minus y1, x2 minus x1, it's all up to you. Let's see here. 3.4.2 says the equation of the tangent PB is in this format. Well, we need to calculate the equation of the line PB. Oh, yes, PB. Okay, so the fortunate thing is PB is perpendicular to the gradient that we just worked out. And B is a point that the graph passes through. So I think this is going to be pretty straightforward because here we can easily say M1 times M2 is equal to -1. The gradient that we have is -4 over 3. So it's like -4 over 3. And then here, you can divide both sides, right? -4 over 3. And then here we have M2 is equal to 3 over 4 with positive values. So the big idea is we have the gradient now. We just need the y-intercept. To get the y-intercept, we can sub in a point that the graph passes through, and you can actually use this formula. Y1 minus y2 is equal to m x1 minus x2. Here you have to sub in, no. Bro, it's not like that. It's y minus y1 is equal to m x minus x1. This is a coordinate that the graph passes through. This is the gradient. The graph passes through 8 coordinates. 0. Yes, does it? And then we have the gradient. So this is going to be a gradient of 3 over 4. And then x value is like 8. Y value here is a 0. This is like 3 over 4x. 3 times 8 is like 24. 24 divided by 4 is a 6. There you go. There's your answer. And what we do know is that this is the x value. This is the y value of the y value here is like -6. See. So let's keep things moving. 3.5 says the following: write down the equation of the tangent SKL. So writing down the equation of the tangent SKL, well, this one is quite straightforward. The reason being it's a horizontal line. So let's see. So what you do know is the radius is a 5, right? And the y value here is a 4. So if this is 4, you go up 5, you can end up at 9. So the equation has to be y is equal to 9, bro. Come on. Y is equal to 9 is our equation of our tangent. Let's just write that down. Y is equal to 9. 3.6 says show that L is the point 20 coordinate 9. So we have to find point L. Right? Where is point L? There is L. This is L. There we go. We have to find this point, right? We have to find that the say we should call show it's 20 coordinate 9. So we know its y value is at 20. Now, I mean, we know the y value is 9. To get the x value being 20, what can we do? Well, this is easy because we have the equation of this line here. We can just sub in a y value of 9 in the equation that we just worked out, you see. So let's do that. This is copy. Let's put in here a 9. And then let's see here. Y is a 9, right? So it's 9 is equal to 3 over 4x minus 6. The 6 goes over, it's like 9 plus 6. So that's like 15. And then we have to divide by 15 on both sides, you see. So, I mean, we have to divide by 3 over 4 on both sides. 3 over 4, 3 over 4. There we go. There we go. So this cancels this. And what do we have now? The calculator. Calculator is kind of fast. So this is gonna be like well, I do think that we should just use a calculator. It's gonna be like 20. Because it's like 15 divided by this, right? So we're gonna flip in. Bro, this is wrong. My calculator is literally at my feet, but for some odd reason, this boy don't wanna. So it's gonna be no, it is fine. This is gonna be 15 times 4 over 3, right? Which is gonna be a 20. I think it is a 20, yeah. Not I think, I know it is, because 15 divided by 3 is 5. 5 times 4 is 20. There we go. Oh, which is the answer we're supposed to prove anyway, so that's like kind of obvious, you see. Therefore, L is 20 coordinate 9. And remember, this is the exact exam that I wrote in metric, so this is quite interesting. It's on the easy side, to be honest, don't wanna lie. Calculate the length of ML. Insert form. Where is ML? ML, there's M here, there's L there. We need to calculate the length insert form. So we're gonna have this 5 and 4 coordinate. I mean 5 coordinate 4 is what you may call is the length of M, right? Whoa, come on. Right, let's just write it out. 5 coordinate 4 is the length of M, or rather is the coordinate of M. L is 20 coordinate 9, you see. So in this situation, what are we gonna get? Yeah, distance formula. Distance formula is going to be equal to the square root of x2 minus x1 squared, y2 minus y1 squared. And then this is going to give us 5 minus 20, 5 minus 20, 4 minus 9. This is going to then give us minus 15 squared. And then 4 minus 9 is what? Minus 5. And then this is like 225. Bro, the way I'm busy taking risks with this, let me just lean and get my calculator, like literally on at my feet. It's 225, so at least the mental math still works, you know. At least it is still working. Yeah, so that looks fine. it's going to be 225 plus 25. So it's technically going to be 250 under the square root. So this is the square root of 250. And remember, they said we should leave the answer in third form. So let's see what the calculator gives us. It's going to give us, yeah, 250. Square root of that is definitely not something that is easily written in set. So if you leave it like this, I think you should at least get your mark. But normally what you can do is you want to find the highest number that you know that's a square number that's close to 250. Now let's see here. Wait, hold on. The calculator should give us square root of 250. Yeah, 5 square root of 20. Don't have to do anything funny. 5 square root of, no, 5 square root of 10. There you go. And then here, 3.8 says determine the equation of the circle passing through KLM, right? KLM in the form this. So where is KLM? K, L, and M. So the thing to note is that if a circle is going to pass through K, L, and M, we already know which line is going to be the diameter. And this is a very common question, very, very common. They like questions like these because you see, it's almost, a mixture of like Euclidean and analytical geometry. Because if this is a 90-degree angle and they're talking of the line KLM, means that you have a circle that goes around these points here. You see, let me just try and make it a bit more circlish because it's more of like an oval, but the point is, if you have a circle here, you see, if you look nicely at the circle, right, it technically, snap. Go to the back, man, go to the back. So if you look at this circle, right, it is technically going to have this as the diameter here. This is going to be the diameter. See, there we go. Now, because we know that an angle subtended by the diameter of a circle is got 90 degrees. So as long as this is 90, this is the diameter, and we have the length of PM. We worked it out just here in set form right now. I mean, of LM. So we have it. So we have the diameter, which can give us the radius. So the radius of the circle, we need it, and we need the center. The center is going to be the midpoint, right? This is 20 coordinate 9. This is 5 coordinate 4. The midpoint is going to be, let's see, 20, no, x1 plus x2 over 2, y1 plus y2 over 2, and let's see, the first x value that we get, that we have is like 5, so it's like 5 plus the 20 over there, over 2, and then you have 4 plus the 9 over there, so 4 plus 9. There you go. And then let's see, 5 plus 20 is like 25 over 2. That's like 12.5, if you will. And then this is like 9 plus 4. That's like 13 over 2. 13 over 2, that's like 6.5, if you will. But as fractions, I think these will be better, 25 over 2, 13 over 2. So now that we have the midpoint, I don't even know I'm writing it here, but here we have just done it, and now we can easily put it into our equation of our circle. We can just get the radius. R is going to be equal to 5 square root of 10, the whole thing divided by 2. Well, you can actually, fortunately, just leave it like that, like you actually can. So this is like x minus p squared, y minus q squared is equal to c squared. So this is like x minus 25 over 2 squared, y minus 13 over 2 squared. C is the radius, it's like 5 square root of 10 over 2 squared. Thirteen over 2, 5. There we go. Let's see. Let's move on to the next question. Question number 4, right? It says in the diagram below, E and F respectively. So where's E and F? There's E here, there's F there. E and F respectively. No. Yeah, E and F respectively are the x and y intercepts of the line having this equation. So they gave us the equation. And the thing we know is automatically, as long as they've given us the equation, we automatically have the y-intercept. So they said here, the line through B, where is B? The line through B here, making an angle of 45 degrees with EF. If that is 45, this is going to be 45 also. I think it's worth noting because, I mean, like, since we're dealing with angles, you know, I'm already seeing things like this triangle here. It has an exterior angle over there, which is equal to the sum of these two, you know, all that is already something we're seeing because it's so obvious what they're going to maybe ask in the future. Because as long as they've given an angle, they're going to ask something in the future. This is equal to 90 degrees. Let's just carry on. So it then says here, yeah, it is equal to 45 degrees with EF as shown below, and has X and Y intercepts. Wait, what? Has X and Y intercepts A and M. Okay, oh, the line has an X intercept of A and a Y intercept of M. Okay, cool. So they've given us that information, which is okay. It is okay. Determine the coordinate of E. Where is E? E is this point here. Okay, not a problem. So E is fortunately the Y, the X intercept of the straight line that we already have an equation for. So this is like Y is equal to 3x plus 8. 3x plus 8. And then X values are 0. No, Y values are 0. You see, 3x plus 8. And then this is like negative 8, 3x, right? Divide both sides by 3. What do we get here? Negative 8 divided by 3 is like negative 8 over 3. Perfect. So from here, well, remember they asked for a coordinate. This is just the x value. So fortunately, we know that the y is just a 0. So this is going to be negative 8 over 3, coordinate 0. There we go. You'll get your 2 marks for that. Let's move on. And then it says here 4.1, right? Calculate the size of DAE. So where is DAE? There's D here, there's A here, there's E there. This is DAE, right? This is what they want us to calculate. So let us work that out. So that angle, let's see how many marks they offer. At least maybe, well, I was expecting maybe like 4, but I guess it is what it is. DAE. Well, that's kind of, well, it seems a bit, I guess it is what it is. So if you're gonna work at DAE, the first thing I can safely say is, yeah, we have the equation of this line. So remember, I already stated that this is 45 because of vertical opposites. And then here if we can just get this angle, we're fine, because as long as we have this angle, it's the angle of inclination, right, of this line here. So you can get this angle, And then we can use the law that says that an exterior angle of a triangle is equal to the sum of the opposite interior angles. You see, there we go. Is equal to the sum of the opposite interior angles. So with that being said, let's see. We have, we can get the angle of inclination here. So we can label this theta if we want it. So tan theta, the gradient of this line here is just a 3. So let's see here. M is equal to tan theta. Gradient is a 3. Tan theta. Shift tan negative 1. Shift tan 3, right, with theta here. In the calculator, let's see what we get. Shift tan with a 3. That's like 71.57. 71.57. Okay, 71.57. And then we have determine the equation of AB in the form y is equal to mx plus c. Okay, determine the equation of the line AB. There's A here. Here's B. Huh? AB or AE? No, there should be AB. But where is B? B. Oh, it's here. There's B. Wait, we didn't finish. What am I moving on for? So this is 71.57, right? Wow, that's so weird. 71.57. We know that this angle here, DAE, is going to be 71.57 minus the 45, because these added up together should give us 71.57. Let's actually write it out. DAE is equal to 45. No. Let's do it properly. 71.57 is equal to DAE plus 45. You see, you can even write a reason. It's not necessary for analytical, but just, you know, you can actually put it there. Exterior angle of a triangle. So here, this is going to go over to the other side. And then DAE here is equal to, what do you get? 26.57. DAE, that's like 26.57. Okay, and then what? And then here we have 4.3, right? 4.3 said determine the equation of the line AB in this format. So yeah, fortunately, this one is not going to be too difficult, because the line AB, we can use the angle of inclination to get the gradient. So the angle of inclination is like 26.57, right? So what we can do is, this is 26.57, and then we also have a point that the line passes through. So yeah, I think we're good. We can get the gradient, and then we can use this point to get the y-intercept. So our gradient, we're going to say m is equal to 10. We can use this variable. The angle we have is 26.57, right? And the gradient, let's see, 10, 26.57, it's going to be equal to 0.500. So that's approximately a half. So here, now that we have the gradient, we can say y minus y1 is equal to m x minus x1. And then we have what do we have next? We have y minus y1, right? So it's like what? Let's see. Y minus y1, x minus x1. There's like what do we have? We have what is that thing now? How am I even? Yeah, so it's like, it's 1 and 5, right? 1 and 5x1 y1. And then we have what do we have here? We have gradient is a half x. The x value was a 1, the y value was a 5. It's a 1 and a 5. So y minus 5, you see. If you multiply inside, you have a half x, negative 1, positive 5. So you have a half here, negative a half plus 5. Yo, we can get that in our calculator. Let's see what we're gonna get here. Da 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 da. Yeah, so in our calculator, we are getting here 9/2, which is accurate. 9/2, definitely accurate. So that's fine. But then wait, 5.4.1. What did we ask? What did they ask us? Coordinates of A. So let's see here. We're gonna have minus 9/2. No, 9 plus 9/2, bro. There's your answer. Not so bad. This is going to be x over here. Let's move on. If AB has this equation, right? Determine the coordinates of D. Yeah, if AB has this equation, determine the coordinates of D. So where is AB? Wait, we just got the equation of AB. So the funny thing is, fortunately, our answer, we know it's correct. So if they're saying we should determine the coordinates of D, where is D? D is a point on the line AB. So, it's a point where two graphs meet. We have two equations, right? 3x plus 8 and the one that we just worked out. So D is a point where they meet. So that's not an issue. But I think I see why they gave us the equation in this format here. I think, I know, it's all more or less the same, Our equation is accurate, so we can just make the equations equal to each other and then work out where the x value where they meet, and then eventually we can work out the y value where they meet. You see, so since one side is a fraction, the denominator here we could put 2 as the denominator. Since one side is a fraction, we can make this side a fraction as well, meaning we'll be able to cross multiply. You see, 2 times the top part, 2 and 3x plus 8. 1 times this part is just x plus 9. And then you have 2 multiplied inside here, that's going to be like 6x. 2 multiplied inside, that's going to be like 16. And then you have x plus 9. And then you have x minus, 6x minus x, that's like 5x. 9 minus the 16, because the 16 is going to go over to the other side. You're going to get negative 7 on the other side. And then obviously here you can divide by 5, divide by 5. It's going to give you x is equal to negative 7 over 5. You see? So that's like negative 1 point something, which is fine. It's not bad at all. It is okay. So all this being said, let's see here. We have yeah, let's move on to the next question. So here, since we have the x value, the y value, we can get it by throwing in the x value into any of these equations, right? So let's see here. Y is equal to 3, negative 7 over 5 plus 8. What is that in the calculator? Let's see. Let's just put all this in the calculator. 3 times negative 7 over 5. And then you have here plus 8, right? This is like 19 over 5. There you go. So the coordinate of D, negative 7 over 5 and 19 over 5. So the one habit I noticed is that I tend to always forget that with the coordinate, we need to give the x and the y value. So normally whenever I get the x, I always like move on, and yeah, that's quite dangerous. So always try to make sure that you get the x and the y value when they ask for a coordinate. Question 4.5, right? It says here, calculate the area of quadrilateral DMOE. So let's see what DMOE is. There is, where's this thing? D, where's point D again? Oh, question 3, oops. DMOE. So I have to calculate the area of this quadrilateral over here. Okay, so this quadrilateral, it's not a trapezium. It just looks like an everyday quadrilateral. And obviously the question would be, what's the easiest way to work this out? And judging from the way things are looking, what's the marker location? It is it 5 or 6? 6, yeah. Yeah, so this is the kind of a question where it's obviously not going to be like one of those things where we look at it and we immediately see the answer. This is the kind of a question where you do have to think outside the box just a little bit, but not too much, because fortunately we have quite a lot of information in our sketch already. We have angles, etc. So let's see this quadrilateral. One thing for sure is that we're probably gonna need to work out the area of this quadrilateral in pieces. But the one thing that I'm already seeing is that this quadrilateral is part of is inside this big right angle triangle here. And then the other thing that I think you also just saw now as I drew this is the fact that we have this triangle here. You see, so it looks as though we can take the area of the right angle triangle and we can remove the area of this triangle here, because the area of the right angle triangle is quite straightforward. And the area of this blue triangle, we can just do half base times perpendicular height. We have the coordinates of D. So the coordinate that we had for D, negative, negative what? Negative 7 over 5 and 19 over 5, which is pretty, well, it's a strange coordinate. I mean, like, it's not like whole number or anything, but that doesn't mean that it's wrong. And we also had, I believe we got A. Did we? Did we get A? Okay, we got E. Let me see if, I think, why am I forgetting so fast? We got E. We have the equation of AB, so that's definitely useful. Yeah, we can easily get A there because we do need A. We need A. A is just the what you may call. A is the x-intercept of the straight line AB. Wait, is straight line AB? Yeah, yeah. If AB is a straight line, I mean, like, obviously, it then means that A is a point on that line. So here we can just throw in the y value, which is a 0, for us to get the x value of what you may call the x value of A, because it seems like we definitely do need it, you see. So let's see here, the y value is a 0, so a half x plus 9 over 2, this goes over, negative 9 over 2, that's a half x. And then you can just divide by half, you see. So this here divided by a half, that's what x is if you divide by a half on both sides. So we're going to have here negative 9. Yeah, negative 9 coordinate 0. So that's quite interesting, is it? Yeah. Dividing by a half. Yeah, it's fine. It's fine. So with that, we have all our information now because we also have M, remember? M is the y-intercept of our straight line. And they gave us the equation of the line. Well, we got the equation of the line AB, so its y-intercept was, I think we just got it now, right? So it was like 9 over 2. So this is the y-intercept here, right? 9/2. There we go. So we have all the information we need. We're going to take the area of this right angle triangle over here. At the area of this triangle here, let's just say this is AMO. So AMO, triangle AMO is going to have base, which is AO, times perpendicular height, which is MO. So this one is straightforward. Half AO is definitely 9 units, and then MO is 9/2 units. You see. So this is going to be 81 units squared. Yeah. Is it? No, bro, come on. Bro, 81 divided by 4. This is why I should just use a calculator. Because with a calculator, you don't make mistakes out of just excitement, you know? Because when your answer is, when you're flowing and things look nice, yeah, that's when you can easily just make a silly mistake. So that's that triangle. And then we can work this one out. I think, well, whichever way, let's just work this small one out now. We can, yeah, we're just using random colors now. And the area of this triangle in particular, half base times height, right? So E, the distance between this and this, yeah. If you're gonna find the distance between any 2 points, you have to take the bigger one and you subtract the smaller one, you see. But then this is distance, so we don't even have to overthink it, you see. So let's see here, -8/3 minus -9. It's giving us 19/3, you see, because it's this value minus that value. Whenever you want to work out distance, always take the bigger number and just subtract the smaller number, you see, which is what we did. We took this bigger number minus that one, you see. Our perpendicular height is just going to be the y value of D, which is just 19/5. So our area here of triangle AGE, triangle AGE is also equal to half. The base is AE, and then the height is, we can, what we label it, we can just say, let's just put a tiny h there. Let's just put h in there. And then let's put in our values, right? A half AE, as we say, that's just 19/3. Perpendicular height is like 19/5. Okay, so many 19s, that's a bit promising. So a half times the base, right? Let's see here, times the height. Half base times height. There we go. That's like 361/30. So it looks like we're practically done now, because I mean the area of the quadrilateral is just in our face now. So we can say here, area of DMOE is just going to be equal to 81/4 minus 361/30. You see, and let's see what that gives us. And then we're going to put it in as a decimal also. You see, 81/4 minus 361/30. This is going to be 493/60. See, which is approximately equal to 8.22 units squared. There we go. That's absolutely fantastic. Question number 5 says the following, right? Well, that's like good. Anyways, question number 5 says, in the figure below, ACP. Where is ACP? So it looks like this is trigonometry. Yeah. There's a 2D trigonometry. ACP. Is it 2D trigonometry? We'll find out. Say ACP and ADP. ADP. Is it ADP? What's that? Security company? ABP? ADP? Yeah, it says here below ACP and ADP are triangles with angle A equal to angle C equal to 90. Yes. So we're dealing with the right angle triangle. Very useful piece of information. And then they said here CP is equal to 4 square root of 3. AP is equal to 8. So we can easily get this if we need it because of Pythagoras. DP is equal to 4. PA bisects D PC. Let's read that again. It says here AP. Okay, so this line here cuts this angle in half. And then they said here, let CAP equal to X. And then let this one here equal to Y. So this here equal to X, this here equal to Y. Yeah, so it's definitely a 2D shape. Let's see. They then said, yeah, show by calculation that X is equal to 60. Very easy question, straightforward trigonometry, because this is an angle, right? You have the opposite and the hypotenuse. So we can use sine X. Sine X is equal to opposite, which is CP, over hypotenuse, which is AP. You see? And then we're going to have 4 square root of 3 over 8 with sine X, working out X. So the thing is, sometimes in grade 12 papers, right, you will get some questions that are shockingly just straightforward. In those kinds of questions, yeah, don't mess up, because I mean, like, you can get very easy and direct questions in your exams. It's quite normal, you see. So don't be scared of normal questions that have normal answers. So here, this here in our calculator, shift sign, X here is going to give you a 60 in your calculator. And then, well, you could have, yeah, let's just move on. The other thing is, let's see, next question says here, calculate the length of AD. Calculating the length of AD, well, it seems like we could use, what you may call, it looks like we can use one of the formulas for triangles, you know, either the cosine rule or the sine rule, because it's not a right angle triangle. It is a 4-mark question, so let's see. What do we have here? We have 2 sides given, but then we technically have an angle, because you see this angle, we can just work it out by working at the one inside this triangle. This we already worked it out to be a 60. So if this is a 60, this automatically has to be a 30. You see, because interior angles of the triangle add up to 180. So if this is 30, this is automatically 30. And if we need AD, we can automatically just use the cosine rule. So that's quite straightforward, you see. We need to tell them all this information. So CPA is equal to 30. CPA is equal to 30 degrees. The reason is interior angles of a triangle. Angles of a triangle. And then once that is done, we can say here APD. We can say therefore APD is equal to 30. That's given in our sketch. They said those two are equal to each other. So here, our cosine rule, we know that since we're working at this side, the side that's on its own is the one you write out first, according to your formula. So here, AD squared is going to be equal to AP squared, AP squared plus DP squared, minus 2 AP DP cos the angle opposite AD, right? The angle opposite AD is APD, which is how your formula works, because in your sketch, right, if you're going to use the cosine rule, you need to be given two sides and the angle in between those sides. And then in your formula, the side that is opposite the angle is the one that goes on its own in the formula. Let me see. So this would be like the angle, the letter A, this would be the side A. And this could be B, this could be C, this could be tiny c, this could be tiny b. See, that's how your formula works. Because remember, on the formula sheet, it's written a squared is equal to b squared minus c squared. No, b squared plus c squared, and then 2bc cos a. The angle goes with that side. So that's why here the side here went with this angle. Putting in values into our formula, fortunately, we have everything. AP and GP. AP is 8, GP is 4. So it's like 8 squared plus 4 squared minus 2, 8, and 4 cos. What's the angle here? The angle is just 30. Now to get AD, we have to square root both sides, you see. So let's actually just put this and this is the square root. So we can just throw all this into our calculator. Let's see what we're gonna get here. Let's see here, 4, 2 squared, yada, 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 yada. So this is going to give us square root of, well, I guess maybe writing one step is not gonna hurt. This here is gonna be 64 plus 16 minus 16 times 4 is what now? Yeah, 2 times 8 times 4 is gonna be 64. And then cos 30, according to the calculator, or cos 30, it's something we already know. It's going to be square root of 3 over 2. Okay. And then this, I think you can just then put everything into your calculator. I don't think it's an issue. It's giving us 24.57. So this here is what we have under square root, right? And then obviously, the square root of that, let's see here in the calculator. Let's see here, it's going to give us 4.96. That's what AD is going to be equal to. You see, so that's fine, nothing crazy. Let's keep moving forward with what we're doing. So getting y is not so bad now. Let's just put this here, 4.96. Getting y is also straightforward now, because to get y, you can actually just use angles inside this quadrilateral. Because if this is 90 and this is, oh, oopsie, not exactly, huh? Well, we can use the sine rule. It's definitely something we can do, because you have an angle and its opposite side. You need an angle, but the opposite side is given. So yeah, the sine rule. The sine rule, you can write here sine. Since you're working out an angle, you can say sine y over the opposite side. Let's see here, that's dp, bro. dp equal to the angle here with the opposite side. So sine APD, the side here is 4 point something, that's just AD, you see. Of which here, since we're looking at y, we can put here sine y. ADP is 4. The angle that we have APD is 30, and then AD is 4.96. So you see, this helps, you know, it helps to be confident about your answer because you can then confidently use it in follow-up questions, just like what we're doing here. It's out of 3, so I mean, you really don't want to be losing 3 marks over a question. Let's see, the next step here, we can just multiply both sides by 4. What we're gonna have here, it's gonna be equal to, ooh, somebody's hungry. 4 sine 30 over 4.96. And then we can just put in our calculator, shift sine the whole thing. 4 sine 30 with 4.96 down here. The value of y, what we get is the value of y. So the value of y is, let's in the calculator here. So you want to make sure that you put everything properly, otherwise you're going to lose marks for nothing, you see. So in the calculator, let's see here, it's giving us 23.78. Okay, there we go. Nothing crazy, nothing major. Let's just keep the ball rolling. See, so let's keep the ball rolling. Prove the identity. We have the left side, we have the right side. So if we're going to prove this identity, this is how you can do that. Yeah, so proving identities, the one thing is, well, in this situation, you want to go for, you need to be aware of your trigonometry laws. So here I'm already seeing the reduction formulae. So let's go with that angle. And you can like break down each of these, maybe like one by one or something. For example, cos 180 plus x, right? Cos 180 plus x. If you just have, don't forget the squared, right? We'll consider the squared just now. But if you just think of cos 180 plus x, and you think of our cast diagram, you see, let's use the cast diagram. If we're going to be using the cast diagram, come on. We have CAST. 180 plus is in this quadrant. You see, and in this quadrant, cos is a negative. You see, so obviously cos 180 plus, it is equal to negative cos x. But the thing is, if this is squared, it means that this is squared, meaning that here you get a positive cos squared x. You see, that's important. And then the next one that we can break down on its own before we do everything together is 10x minus 180. You see, 10x minus 180. The one thing I always say is, in your Cartesian plane, if you have these two swapped around and one of the number is a minus, you can just write them with the number in front, negative 180, and then plus x, right? Meaning, in your Cartesian plane, instead of going anti-clockwise, you would go clockwise first, you see. You would go 180 degrees, right? And then the moment you're plusing x, you would come back. You see, meaning you'd end up in this quadrant where 10 is a positive. So this is 10x. You see. And then here, sine 720 minus x. The one thing I always say is that if a number is bigger than 360 and you're working with that number, what you can do is you can remove the highest multiple of 360. So here 360 goes in here exactly twice. You see, so automatically here we're going to have sine with minus x because it's 0 minus x. And then what we do know is, as we said, if you're going to have a negative, you go anti-clockwise. I mean, you go what you call clockwise whenever you deal with the negative. So going clockwise, this is just x. So if you go clockwise, you end up in this quadrant where cos is positive. So this is just negative sine x. But what we do remember is that any angle here, if this, just put this here, if this value here is a negative, this will always be a negative if you're dealing with sine or tan. It's only when you're dealing with cos that you have a negative here and this is a plus, you see, because of, our cast diagram also shows us that. So looks like we've broken down all that can be broken down. So let's just write out these pieces of information in our question. So here we have cos squared 180 plus x, right? That's going to be cos squared x. So cos squared x. And then we have 10x minus 180. That's like 10x. That's like plus 10x. And then here you have minus sine x. So wait, you have minus sine x and then a positive cos x. So let's just put that in brackets. Minus sine x cos x. And then we should show that it is equal to cos 2x. So this we sorted out, this we sorted out, this we sorted out. So this is all one thing, right? So obviously you can, here we're dealing with the left hand side. So here we can have cos squared x. This whole thing can become a negative. And then since we see 10x, we can write it as sine x over cos x. And then here, this times that gives us sine x and cos x. This we can maybe put it over 1. But because you're multiplying, it means that at least this you can cancel that. And then here you can have cos squared x minus sine. This times this gives us sine squared x. And then this is definitely something on your formula sheet. This is part of the double angle for cos. So this is just equal to cos 2x. And then you can say, therefore, the left-hand side is equal to the right-hand side. So this was definitely on the easy side, but it was an okay question. It was an okay question. Let's just keep moving on to the next questions that we have to deal with. Let's see. Here it says, use this expression is equal to this to derive a formula for sine negative b. 6.2 says the following. Use this expression here. Let's see, what does it say here? Use this expression, right, to derive a formula for sine alpha minus beta. So to be honest, this is something I low-key am trying to remember from the back of my head. So let's see, what we do know is that cos alpha plus beta is equal to this expression. This is fine. If we're going to use this formula to derive a formula for sine alpha minus beta for only 3 marks, this is the kind of a question where you don't necessarily need to like guess or that. This is the kind of a question where the method that you use to work this out, it's basically, it's very systematic. Now, the one thing I do remember these kinds of questions is when you are working with something like this, you can see here, this is alpha minus beta, but then here we're given alpha plus beta. So my first instinct is to change this to cos alpha minus negative beta. And then to work with negative beta while expanding this formula. So let's do that and see where we end up. So here we have cos alpha is still just alpha, and then here we'll have cos negative beta. And then here we have negative sine alpha, but then here we'll have sine with the negative beta over there. Let's see what we end up with if we somewhat carry on with what we need to do. So this is the first option. The other option I'll be thinking of is something like 180 minus or 180 plus, something along those lines. But let's see where this ends up. Well, unfortunately, this here is gonna still lead us with cos beta here, and then here this is going to be negative. sine beta. So this here end up as a plus. So this root is not working. So we have to think of something else. Let's say I had thought of cos 180 minus beta. Well, one or the other, what does come to mind is the fact that if you are thinking of what they've just given us in the expression that they've given us, we know that, yeah, trying to work from here to get there is definitely not helping. So you're better off just starting from here and then doing what you can to expand your expression. So normally if you want to expand your expression and you're starting from sine, you can use 90. You see, so remember we know that 90, cos 90 minus a specific value. This is equal to sine whatever value you'll be dealing with, you see, based on the Cartesian plane. So in our case, where we see x, we can just drop in the alpha minus beta. So here we can have sine alpha minus beta, right? We say that it is going to be equal to cos 90 minus alpha minus beta, because where we see x, you see here where we are seeing x, you see we're just dropping it in there. You see, so we see alpha minus beta, we just dropped it in there. Carrying on from here, we will end up with something where we at least have a plus in between our expressions. So if you multiply, in this situation, maybe think to yourself, do you now multiply inside or what? And yes, you may want to multiply inside your expression. But then the moment you multiply inside your expression, you need to be careful what you want to end up with. You want to end up with a positive alpha. Wait, you already have a positive alpha and negative beta. You at least want to end up with an expression that's like expanded. Well, fortunately, from our formula sheet, we already know that this is supposed to come out as sine alpha cos beta. Since there's a minus, you'll have here cos alpha and then sine beta. You see, this is what we already know. So we should try and aim for that. We should try and aim for something where we at least have a minus in the middle. So carrying on inside, you can have cos 90 minus alpha, and then you'd have a plus beta. So this is where you have to ask yourself, okay, remember we have to end up with at least something that can allow us to make use of this. Because if you cannot make use of that, it's almost useless, this information that they've given us. You see, so the one way to go about answering this kind of a question is, if you're gonna have these two, right? Wait, I meant to put alpha here, not beta. Let me put here alpha. There we go. So in this situation, you may be thinking to yourself, okay, fine. What do you do with these three terms, and which do you group together? You see, because the ones that you group together, you don't do it randomly. Now, the idea is, since you want to end up with at least sine alpha minus beta, you may want to make sure that at least the 90 plus beta is on its own, and then the minus alpha is on its own. And what I mean by that is the following, or rather, you can, it's actually up to you what you want to do. You see, you can either have these two together, or you can have the 90 and the beta together. It's up to you. But in this case, we can just have cos 90 minus alpha. Let's look at it as one thing. And then beta, let's look at it as something else. Meaning we can now use this long formula. You see, because something plus something allows us to expand it like that. So here we can have cos the first thing here. So we'll have cos 90 minus x. And then we have to have cos the second thing, which is going to be cos beta. And then there's a minus in the middle. And then we have sine the first thing, which is the 90 minus x. And then here we have sine with whatever this one will be. So if you expand, if you carry on from here, 90 minus, we already know what that is according to our cast diagram. 90 minus x. I keep saying x. Bro, we're dealing with alpha, bro. Excuse me. Excuse me. That's just a silly, that's just lack of focus actually. And I keep doing it like, wow. Just removed an x and put an x again. Yeah, this is supposed to be alpha. So carrying on from here, 90 minus alpha, that's just going to be alpha. Cos beta is still just going to be cos beta. Ooh, what's going on here? Oh. So I'm looking at this and I'm thinking, oh, no. If you're dealing with 90, you always change it to the opposite, to like to another trig ratio. So from cos, it's going to become a sine, and 90 minus, that's a positive quadrant. And then here, sine minus, sine 90 minus, this is going to give you a positive cos alpha, and then sine beta. You see, and you see on the left hand side, you have here sine alpha minus beta. So that's going to be worth 3 marks. So you can see for future reference, the only thing you can remember is from sine, you have to change it to a cos, right? And then you can just carry on and you will have your answer. Whew. Yeah, but again, for deeper explanation on everything that we're going through, you can always sign up for the online courses on our website. The link for that is in the description. If you have any questions, you can always just hit me up on Instagram and then I will be able to assist. Here it says if sine 76 is equal to x and cos 76 is equal to y, show that this expression is equal to sine 62. So the one thing about maths is you need to be confident. You need to believe in yourself. You need to know that if you're going to write something down, you need to be confident about it. And the way to gain confidence is to know the tools that you have at your disposal. So if you're going to end up with something like this and you want to show that it is equal to sine 62, don't be scared to create an expression like this. Because look, x squared minus y squared is just you writing here x squared minus y squared, right? You know that x squared is just sine 76 squared. And then the y squared, you know that it is just cos 76 squared. Now, you know the tools at your disposal when you're dealing with sine squared and cos squared are the following. You know that sine squared x plus cos squared x. You already know that this is a 1. Furthermore, you also know that we have the double angle of cos if we ever need it, like cos to alpha is equal to one of 3 things. And one of the main ones, or one of the ones we know that looks like what we may at least be dealing with, is this one. You see, now for you to end up with something like this, it looks like it's easier to do as opposed to ending up with something like that. So here you can see that if you take out a negative here, right, the cos is going to be a plus. So let's do that. And this will be a minus. So you will be doing this based on the tools that you have, which is where confidence comes from. Confidence comes from the tools that you know you have. So here you already know that your double angle will tell you that whatever this angle is, it's the value that goes there, you see. So here you have negative, and then here cos 2 times 76. Let's see. In a calculator, 2 times 76 is like, is it not like 100 and what? 100 and, yeah, no, I don't even know why I'm using mental math to work out such a question that I can just get from the calculator. It's 152, yes. So here we have negative cos 152. So trying to work out this question out of 4 to eventually end up with sine. Remember, if you're going to go from a cos to a sine, you have to use 90. So here we can see the easiest way to get 90 here is 90 plus 62. So you see in here we have cos 90 plus 62. And then this is where you have to know your knowledge on the quadratic, on the cast diagram, you see, CAST. 90 plus is this quadrant, you see, and only sine is a positive. So here, if you go 90 plus, you're dealing with the cos, right? So this negative is still just here. However, when you work out cos 90 plus, this comes out as negative sine 62. And then a negative and a negative give you a plus. There's your answer. You see? Confidence. You need to be confident. This is where you're going to gain confidence and tools, because I promise you, all the courses are good, but to be honest with you, the trigonometry course is on another level, because it's the one course where, well, all of them have their own speciality. But the thing with trigonometry is it's such a hated topic most of the time, but it can easily become the topic you love the most, because the tools that you need to answer your questions, there are so many. You have so many tools to use. That's why trigonometry usually ends up being one of the topics that people actually like. Let's move on to the next question. Question number 7. It says, in the diagram below, the graph of f is equal to this expression, and it is drawn for negative 90 until 270. So you have negative 90 here, you have positive 270 over there. Let's see, and then it says here, write down the range. The range will always be the highest. You always have to check along the y-axis, how far does it go and how low does it go. So it goes as low as 0, and it goes as high as 2. So the range here, you have to say the y values, they're bigger or equal to 0, but they're smaller or equal to 2, meaning they do touch 0 and they do touch the 2. You see, that's 2 easy marks. Moving on, question 7.2 says, show that this equation can be written as that. So this is not a difficult question, it's out of 2. Now, you can see here, this is just a double angle. You see, and that's obviously not a coincidence. So here you have sine x plus 1 equal to, see here you're ending up with something that is sine and sine, you see. So you may probably want to change this to 1 minus 2 sine squared x, you see. Everything on one side, you would get here 2 sine squared x as a positive, and then here this is still a positive value. 1, you would minus a 1 here, so on the right side you'd be left with a 0, and then 1, when you take the 1 over also, you'd be 1 minus 1, so there's just a 0 there. Factorizing, you can see you have to take out a sign as a common factor. So if you're going to write it the way they have it, you can put your sine x here if you want, right? Which is weird, but if you take out a sine x here you'll be left with a 1. If you take out a sine x here you'll be left with sine x. There you go. So that's easy, 2 marks. 7.3 says, hence or otherwise, determine the general solution. So this kind of a question, they've already given you like a head start, because when you need to get the general solution, you at least need to have a factorized expression, just like the one we have. Because remember, this can become this. If it's at least like that, it's easy to factorize. It's easy to get to solve for x, which is basically, getting the general solution one or the other. So you're going to take your first bracket, you're going to make that equal to 0. Let's see what answer we get, and then we'll do the second one also. The first bracket here, we can take the 1 over to the other side, 2 sine x, and then divide both sides by 2. One thing I always say is, if you're dealing with a negative value here, you need to make sure that when you get your reference angle, always use the number without the negative symbol, always. So your reference angle here is going to be 30. Once you get a reference angle, then you use this symbol here to get your actual answers. You see, you're working with the sign as a negative. So according to your cast diagram, you would need to then work with this quadrant and this quadrant. So it's 180 plus, and then 180 plus theta, or 360 minus theta, you see. So with that being said, what do we have here? We have so in the third one, in the third quadrant, right, you would have here your value of x is equal to 180 plus the reference angle, right? And then you'd have plus k360. K is the element of integers. Here your x value 180 plus 30 is like 210 degrees plus k 360. K is the element of integers. So that's fine. With the other quadrant, that's the fourth one, right? That's like IV. You have the x is equal to 360 minus the reference angle, and then plus k 360. K is an element of integers. So you can see once you have gotten the hang of what to do, why you're doing it, it makes all this work like super easy. You see? So this is what you would have, right, for the 1/2 of your answer. You see? So let's put it on one side and let's make space for the other side, which is going to be the side where you will just be working with sine x equal to 0. So in this side here, sine x equal to 0, you will just have your reference angle. You can say shift sine with a 0. And a reference angle, shift sine with a 0, I mean, you're just going to get a 0. You see, that's something we already know. And when we work with a 0, you almost need to then, usually when you work with a 0, you just work with the parts where the graph is a positive. So here your reference angle is equal to 0. So in the first quadrant, you will just be working with x the way it is, and then plus k 360, k element of integers. So that's the first quadrant. The second quadrant, you have 180 minus the reference angle plus k 360, k is the element of integers, you see. So that's all nice and dandy. Here your answer 180 minus 0 is just 180. So there's really no issues with leaving your answer like that. It is 100% correct. You see, you can definitely do something like that. So the only thing now is you may be thinking to yourself, okay, fine. Is this how you leave your answers? And the answer is yes. This is how you can just leave your answers. If you do it like this, you'll be fine. You see, you won't have any issues. So let's move on to the next question, which is 7.4. It says, use the grid on the diagram sheet to draw the graph of this from negative 90 to 270. So let me just take this grid that they've given us and just draw what they want us to draw. So most people like to use their calculator and do the table method to draw a tree graph. That's 100% okay. There's nothing wrong with that. So here though, on my side, all I can see here is this is a standard cost graph. Standard cost graph looks like this, you see, from 1 to -1. However, the moment your value in front of x changes, it means that your frequency has changed. Meaning, if your frequency has changed, remember frequency is equal to 360 over the period. So if the frequency is a 2, right? If the frequency is a 2, it means that your period is gonna be 180, because if you cross multiply here, you have 2p equal to 360, and then p is equal to 180. So that means is in a space of 180 degrees, we have a full graph, you see. And then it means that your graph, after every 180 degrees, you have a full one again, see, going on and on and on and on. So on the left side also, obviously, you would have your graph here going up until like -180, and then it goes on forever. So in our case, we need to draw this graph between 90 and 270. So already, if you know your work, you already know that a full graph, here the amplitude is still a 1, so it's going to be at 1 here. It's going to go halfway. It's going to be down here, and then 180 is going to be back here. So you can just maybe do something like this. There we go. And then here, it would go like that. And here it's like half a graph. On the other side, same idea. Well, yeah. same idea. Needs to pass through there. There you go. You can label it cost 2x. That's your graph. Or you can just label it, you can just say g of x over here. That's still okay. Or g rather. And yeah, you're done. You'll get your 3 marks from doing just this. You see, so let's keep moving forward. 7.5. 7.5 says determine the values of x for which this equation in the interval -90 to 180, you need to work out where these equations are equal. So this is a very straightforward question because we can actually use our image to help us. You see, our image is what can help us in this situation because all that's happening here is the graphs are both moved 30 degrees to the left. You see, 30 degrees left. That's what this is saying. So if you're going to move your graph 30 degrees to the left, or both of these pictures 30 degrees to the left, they're asking you where do they meet. So logically speaking, you want to check out where they originally meet. They originally meet where x is a 0, and they also meet where this is a 1, where x is a 180. And then if you know your work well, if you look at this here, we can see they also meet at other places. Like, so here, if you look at this part, let me just redraw this part nicely so that it's a bit more, yeah, it would at least go up above this graph here. Yeah. So they meet at 4 places. See, they meet somewhere here also. They meet somewhere here also. So here, this x value, we need it. Here, this x value, we need it. But the question in particular, yeah, it needs us to be strategic about our answers, you see, because we don't want to just guess. Because the moment we just guess, yeah, it's not gonna work out. So if you're gonna work out where these two graphs meet after they've both been moved 30 degrees to the left, you need to use a specific method to do it. And this is what we do. So judging from what we said, right, as long as our graphs are moved 30 degrees to the left, if you're gonna find out where they meet after they've all been moved 30 degrees to the left, the one piece of information you can use is this equation. You see, where do the original graphs meet? We already know that they meet at 30. Is it 30? No. At 210, at 330, at 0, and at 180. Those are the values we already have without them. The 0 is part of our answer, 180 was part of our answer, 210 was part of our answer. The -30 here, we would get it by taking one of our solutions, one of our expressions for our general solution, right? And then we need to make k, we can make k a -1, you see. So here, when you work with your general solution, to get like other solutions for your expression, the part that says k is element of integers, it just means where k is. You can throw in any integer value that you want for you to see what your other solutions look like. So this is one of the solutions for the original graphs, you see. So in this situation, for us to find out where these graphs equate to each other after they've both been moved 30 degrees to the left, it means that you can go here and you can just move. If you were to move each of these x values 30 degrees to the left, if it's moved 30 to the left, you would have like 180. Yes. If you move 30 degrees to the left here, you'd have 150. 30 degrees to the left here, you'd have -30. 30 degrees to the left here, you'd have -60. So the green ones are going to be your answers if your graphs are moved 30 degrees to the left. So I can label here final answer, because remember, you want to be communicating with your examiner. X is the element of, you have the different answers, right? It's -60, -60, -30, you have 150, and then you have 180. There you go. This is one way you can give your answers, knowing that your what you may call, knowing that, or rather, let's not say x is an element of whatever. Let's just say x is equal to. You can write it like this: this, and that. You'll be 100% okay. So coincidentally, -30 is part of our answer, but it has nothing to do. It's not necessarily because we took this and we just wrote it there. No, this -30 was where the original graphs meet. But then if you move them all 30 degrees to the left, you can now at least still have -30 as one of your answers because of the others. So let's move on to the next question.
Consider the following geometric series. Okay, so you may be thinking, but it's paper 2. Why do we have a sequences and series kind of question? Well, it doesn't matter. This is something you can always expect. It says you consider the following geometric series, and then it says here, use the graph of G to determine the values of x in the interval 0 to 90 for which these series will converge. So before you even worry about the graph of G, because remember the graph of G, we have it here. See, we drew it here. Before we can even worry about using the graph of G, they say that we need to work out values of x where the series will converge. So your job is to simplify things first before you generate it. So for 5 marks, you can maybe even say at least half of the marks are going to come from you remembering what this is asking you to do. This will always be asking you to work out where the value of r is bigger than -1 or smaller than 1. So because they say it's a geometric series, you can just look at the value of r on this expression, right? So getting a value of r, let's use, we can say this value from 1. So it's clearly the easiest one to work with. 2 cos 2x over 1. You can see that r is just 2 cos 2x. It's kind of weird rewriting, like anything over 1 is just the value on top. So I just wanted to make it very simple. So the value of r, right, is this value, and your sequence to converge if your your sequence will converge basically if 2 cos 2x is smaller or is bigger or equal to, is bigger than -1 or smaller than +1. So what am I saying? Let's just get on. So what you may want to do is you can now work out values of x based on this expression. So working out values of x based on this expression, you don't need to panic. You can just firstly, you're solving for x, right? So if you're gonna divide by 2 here, you divide by 2 everywhere. Well, let me make it the second step actually, so that things are a bit normal. This you're gonna divide by 2. This here, you're gonna divide by 2. This here, you're gonna divide by 2. So with all that being said, you are now then going to have -1/2 cos 2x, and then here you have +2/2. So let's see here. Let's see here. Let's see here. Yeah, so from here we can see that there's no issues. If you're gonna solve for x here, you can do shift cos. You can have it on both x. But before we go any further, this is at least going to be where we need to stop. Here you have to stop here, right? Because here you can at least now answer your question in a way that has some form of method to it. Because if you read the question again, it says use the graph of G. If you look nicely, the equation of the graph of G is cos 2x. Unfortunately, we have cos 2x here now. So this is literally something you can see as a question that's asking, where is the graph of G bigger than negative a half or smaller than a half. And if you look at your image, we already know that logically speaking, our graph of G, we know that it is equal to a half at different places. So if you're going to be looking between 0 and 90, you would only be considering between 0 and 90. You can see that this graph is equal to a half in one spot only, and then negative a half is equal to negative a half in one spot only. So we need to find out what is this x value here, and we need to find out what is this x value there. Doesn't look like it's a difficult question. So if you were to recap reading the question, use the graph of G to determine the value of x in the interval 0 to 90 for which the series is converged. So here you can, if you're gonna work this out, obviously if you're gonna work out where your graph is bigger than negative a half and or smaller than a half, you can just start off by working out where is it equal to negative a half and where is it equal to positive half. So that will give you a place to start. So simply put, you're gonna work out where is equals to x equal to negative a half, and to do that you can do almost like a general solution and the question. So here be careful, because remember we always say when you try to work out anything that is negative and you're dealing with a trigonometric graph, your best bet is to get a reference angle first. So here I would say the reference angle is equal to cos with the half, and then in our calculator, I had it right here. Like literally, it was in my hand all the years. So shift cos a half is giving us 60. So our reference angle is a 60. So what that means is 2x. If you think of it, if you're gonna work in the first quadrant, if you're gonna work in the quadrant where cos is a negative, it would be the second quadrant and the third quadrant, of which in those quadrants, let's just make some space. So it's a 5-mark question, yes, but you should not be scared of, writing enough steps to give you confidence, to give you enough confidence in your answer. So here, the first, second quadrant, we just had the, well, you may be thinking to yourself, why are we even bothering doing all that when clearly getting a number such as 60 is very promising? But let me not distract myself and just get on. So from here, second quadrant, it's going to be equal to, remember we're dealing with 2x here. So the second quadrant is going to be equal to 2x is equal to 180 minus the reference. See? And then you can do the whole k 360, k the element of integers if you want. So just do here, you can get 120. And the fortunate thing is we're eventually going to divide by 2. See? From here, let's divide by 2. Everything gets divided by 2. So you have x. What is this going to be? 60. Coincidence? This is just a coincidence that it's getting us 60 plus k 180. Here's the element of integers. So what you then now know is, obviously, now you're certain that 60 is one of your solutions, because if you put k as 0, 60 is definitely one of your solutions. So if you look at the graph here, you can see that definitely there, it is definitely potentially at 60. So at least 6 one of our answers. To get our other answer, which is going to be like whatever this x value is, we can see that obviously that's smaller than 45. So to get it, you could be thinking, in this situation, it doesn't look like we would get, 45, anything smaller than 45. If you put a 1, -1, yeah, it doesn't look like. So this is where you would maybe begin to think of the other part of what we could work with You see, we work out here with the negative half. Now we can work out with a positive. So here you can say cos to x, y is equal to positive half. And then you say reference angle is going to be equal to cos. Here, obviously, this is just a bit strange, but reference angle is still 60. However, when we are going to the triangle, yeah, I think we can see that it's going to be 5. But yeah, let me not panic. Okay, I'm not panicking at all. Let's get on. So from here, you would need to work in patterns where the cost is a flat, right? So you'd work in the first pattern and the last one. So in the first pattern, you would just work out with 2x is equal to 60, and then plus k360. Here's the element of integers, and then here you would have you can just divide by 2. You have x is equal to 30 plus k360. But in this situation, we don't need to worry about the k element of r part. Just say here x is equal to 60. Just say here x is equal to 30 because if you look nicely at the image, you can easily see that yes, definitely we're gonna have an x value of 60 where the graph is equal to a half. I mean a negative half, and then we're gonna have an x value of 30 where the graph is equal to positive half. So all that knowledge you can see we didn't like struggle for it. It's all based on work that we already need to know. So you'll get your 5 marks in there. So you can see with this kind of question, we didn't struggle. And these are the kinds of questions that you'll find in your online course on our website. Because in something like the trigonometry course, one of the 5 chapters is working on tree graphs. And one of the things you will definitely learn is how to break down trigonometric equations and how to merge questions so that you don't get confused if they seem to have other topics that they are showcasing. So let's move on to the next question. So let's see in the diagram. So we're dealing with so DRCPT, Dr. Cape Town, and also fun text. We should remember stuff like that. It's acronyms that help us remember. Angles on a straight line. The I is just an I. The P here is supposed to remind us of exterior angle of a triangle is equal to the sum of the opposite interior ones. If you add them up, these two, and then here this is just opposites. We know that for fun, these are just corresponding angles. For interior angles, add up to 180. Alternating angles are equal. This reminds us of laws and theorems that deal with tangents, spiral lines, cyclic paths, radius, lines, diameter. So here I think we have our ammunition. The first thing is saying here in the diagram, O is the center. Okay, so as long as you have the center, think of the radius because you automatically can see that these are equal. Very important piece of information because already if this is y, you know that the other side is going to be y also. And then because you are seeing that they're talking about the radius, you have an angle at the center. And angle at the center is double the angle at the circumference. So it should remind you that this is the double 48. So you're gonna have here 96. And you'll know what to tell them when they'll ask for it because they will. And they say here it is the center of a circle passing through A, B, and C. So as you read your question, never just read it. The way I'm reading it now, I'm reading and then talking. That's how you should read it in your head. You read, you go back to the sketch, you look at it, you read some more, you go back to the sketch. So here A, B, and C, they are there, and there, fine. This is 48, this is X, this is Y. So this is a very easy question. So they're asking for X height. We said X equal to double 48, which is 96. Your reason will be angle at center of circle. That's all you need to write. Because the theorem, obviously, in full, it says that an angle at the center of the circle is double the circumference. So that's straightforward. Getting a value of y, we can also see it's not going to be an issue because this is an isosceles. So we can firstly tell them that C2 is equal to B2 because they are base angles of an isosceles triangle. You see? So it's just a two-mark question. So you don't need to worry about things like, telling them that these are equal. It's just they're both the radius length. So that's more like given information. So you can firstly just tell them that these, they're equal because you know that it's an isosceles triangle, and then you can then say therefore, so let's just say this is equal to y, right? This is equal to that, and therefore they're both equal to y. So we can then say here, therefore, y is equal to 180 degrees. You see, the dividing by two parts, you are able to write it out because you're about to. So in this situation, in our calculator, you know that we're getting here 42 easy marks. Easy marks. And that's how you should view a lot of these questions. They should just be easy marks. There's really no need for you to be struggling if you see that the question is just like in your face and there's really no issue in terms of it being difficult or something like that. So moving on from here, let's see. We have here they said in the diagram. Wow, we already have a new picture. Wow, this was really in the diagram. O is the center. So remember our acronyms here. They should help us because don't take your description for granted. Because if you take your description for granted, you end up losing very much. Well, in my honest opinion, I guess this paper was, so far it doesn't seem like the Euclidean is difficult, but let's get on and see. So they spoke of a center. So automatically, as they are talking of a center, you should think of the radius and the diameter. So these are equal, yes. And well, they told us that these are equal, so we should already think of the theorem that says that if a line comes from the center of a circle, if it bisects a chord, then it bisects that chord at an angle. So what that means is that with all this that we have been told, right, if they said O is the center of the circle passing through A, B, C, and D, AOD is a straight line. Yes, that's all fine. And F is the midpoint of this chord. All this is fine. And the other thing is, you see, we should not overlook when they mentioned A, B, and C, and D. It's a cyclic chord. A, B, C, and D. And one of the laws of a cyclic chord is that opposite angles are supplementary. See, so if this is opposite angles are supplementary, it means that they add up to 180. You see, so if this is 30, this has to be 150 because the angles are supplementary. So you need to know those laws. This can remind you of the laws, but the point is you need to at least know the laws and what we say. So this question, we have quite a lot of information. I think it's also going to be an easy one. First thing says we should get the value of F1, and it's just a 2-mark question. F1, we're going to tell them it's a 90-degree angle. F1 equal to 90 degrees. The reason is line from center by that chord. The line from our center is cutting the chord. So that's straightforward. ABC, the angle ABC, let's see, the angle ABC, yeah, straightforward. It's got 150. And the reason is opposite angles of the cyclic chord are also So you can see me writing the whole thing here because I just wrote down the answer. But I guess to be a bit more comfortable, you could say A, B, C, let's put 180 minus 30 and then give them the 150. But if you just wrote 150 and then you still get 100% of the marks because it is a straightforward, simple question and they know it. So let's see another sketch now. In the diagram, AB and AE are tangents to the circle at B. So you see again, our acronyms should help us. They are speaking of tangents, and we have about 3 laws or 3 theorems that do the tangents. One of them is that here A and B are tangents to the circle at B, and the 2 lines coming from the same point, they are equal if they are tangents of the circle where they are touching. So these are equal to each other. So automatically, this is labeled X. You wanna also for yourself label this as X. And then here they said, they are tangents to the circle B and E respectively. And then they said BC is a diameter. So very important information. As long as you have a diameter, that's worth noting. The reason why that's worth noting is because if you have a diameter, you also technically have a radius. And there's a law that says that a radius and a tangent will always meet at an angle of 90 degrees. So you already have that. This is a 90-degree angle because of the laws that you know. Then they said AC is 13, AE is X, BC is X. Where is BC? No, BC is X plus 7. Okay. Doesn't look like a difficult question we're about to go here. It says here, give reasons for the statement below. Complete the table. Diagram 3. ABC is 90 degrees because of tangent perpendicular. AB is equal to X because tangents from the same point. Same point. Easy to marks. Like as easy as I. I don't even know where that saying comes from because it just sounds dumb. As easy as I. But I guess it is what it is. Let's not judge. So this next one says calculate the length of AB. Calculating the length of AB seems quite simple because we're dealing with a right angle triangle. And this right angle triangle, you may be thinking, but we don't have X, we don't have X plus 7, the length here, we don't need it. Because all we need is a formula that we can put in all this information. And because this is a right angle triangle, we can put these lengths inside Pythagoras here, see, and then we just solve for X. So AC squared, which is the hypotenuse, you see hypotenuse is just the one across the 90-degree angle. So you always try and write that first, or always write that on first, obviously. It is equal to AB squared plus the BC squared. Okay, so with all that being said, AB squared is X. AB squared is X squared. BC squared is just this squared, and then AC is just 13. So let's just put this where it's supposed to be, and then we'll get on with our question. Okay, this over here. Let's make this a bit bigger. Okay. So here, carrying on, 13 squared is in your calculator, I think 169, if I'm not mistaken. Yep. 169. Here, you don't have an issue here. X plus 7 squared is just, you can FOIL it out manually, or you can just do it in your head if you want, but it doesn't help out to be doing this. So X times X is X squared, X times that is 7X, 7X again, then 49. And then, because remember, all we did here was we just FOILed X times X, X times 7, and then we start with this one. It's funny me even saying this, but it is what it is. 7 times x, and then 7 times 7. So from here, these are like terms. So you have 2x squared. The 7 plus the 7, that's 14. And 49 over there. This is 169. Everything on one side, you have 2x squared plus 14x. Here, you're going to have 49 minus the 169. So let's see, 49 minus the 169 is going to give us negative 120. Let's see here, negative 120. So the one thing I recommend here is you can divide by 2 across. You can divide by 2 everywhere, but I mean, I usually just jump straight to the quadratic formula. It's just a habit. Because there's really no need. I just jump straight to the quadratic formula. Minus b is going to be, b is a 14, right? So it's like minus b plus minus. How many marks is this question? 4. It is what it is. Well, we wrote this out because of Pythagoras, so let's at least maybe give them a reason why we wrote that. Because it is Euclidean geometry after all. 14 squared minus 4a is 2. C is negative 120. And don't be scared that you have big numbers here and you have not divided by 2. It doesn't matter. The answer will still be the same. The answer will still be correct. So negative 14 plus square root of 14 squared minus 4 a c. The whole thing 2 times 2. Your answer is going to be 5. So here x is for 2, 5. The other one, x is going to be negative 12. So yeah, nothing crazy here. It's a straightforward question. Not so bad. So let's move on. Let's see here. Yeah, moving on from here. Let's see what we can do. Let's see what we can do here. Let's see what we can do. Let's see what we can do. Moving on. I mean, well, the thing is, you have to choose an answer. So obviously, it cannot be a negative. So you have to stick with 5 only, because distance cannot be a negative. So if this is a 5, that makes sense, because this is going to be 5 plus 7, which is 5. So yeah, that's all good. All nice and dandy. Let's move on to the next question.
Question number 9 says, what does it say? It says in the diagrams, points D, where is D? D, E, D and E lie on sides AB and AC. And then it says here, what else does it say? It then says they, yeah, it lies on sides AB and AC of triangle ABC, respectively, such that DE is parallel to BC. And then it says here, GC and BE are joined. Yeah, so I don't know where this is going. Explain why areas of triangle DEB and DEC are equal. So they are areas of triangles, right, that are in between parallel lines. So areas of triangles that are in between parallel lines will be equal because they have the same base, and then they also have the same perpendicular height. So you can view that in different ways, but one or the other. Let us just carry on with our question. So all things considered, let's see, the next question here says, What I mean by that, okay, to explain what I said, same base and same perpendicular height. What I mean is if you look at DEB, right? And if you look at DEC, DE would be the base that they both share. But then the perpendicular height for this triangle, your perpendicular height would be a distance that you can draw out like that. The perpendicular height for DEB would be that. You see, of which this distance is the same as that distance, and then the base is the same. So that's why they'll tell you that the areas of triangles in between parallel lines are equal. Moving on, 9.1.2 says, given below is the partially completed proof of the theorem that states that in any triangle ABC, if these two lines are parallel, then it means that these ratios are formed. AD over DB, so that's like AD over DB is equal to AE over EC. So this proof is quite straightforward because fortunately it deals with the areas of triangle ADE, which is the area of the triangle up here, ADE, the small one, and ABC, the big one. So with triangle ADE, you are going to use it twice. So if you check here, the law here, you have ADE twice. You see, you have ADE over DEB, which is ADE over DEB, and then you're also going to have ADE over DEC. So with that being said, your triangles, let me just lay out something very important here. Your triangles, right? The first idea is that with AGE, you can look at K as the perpendicular height. If you do choose to look at K as the perpendicular height, then it means that this will be the base of your triangle ADE. However, if you look at K as your perpendicular height, this will be the base of the triangle DEB. You see, if this is your perpendicular height. You see, now with the other section, which is this part, ADE and DEC, it basically means that if you look at, wait, I meant, oh, this is H actually. H is, if you look at H as the perpendicular height, then this will be the base. However, if you look at K as the perpendicular height, then this would be the base. You see, let me even maybe draw it in green fully. This would be the base. This would be the perpendicular height. And then for the pink, if you're looking at this specific triangle, the pink is your perpendicular height. Now with triangle AGE, you can clearly see that you can either use K or H as the perpendicular height, and then you'll have this as the base in one instance, and then you'll have this as the base in another instance. That's why these two expressions are written out. So writing them out, actually, here, the area of ADE, right, is going to be a half. The base here is going to be, if you're thinking of ADE, right, let me just try and make things easier. If you're thinking of ADE, ADE is this part here. And then if you're going to put it over DEC, you have DEC here. Its base is EC, the perpendicular height is K. So if K is the perpendicular height for what they're talking about, it means that AE has to be the perpendicular height for ADE. So in this case, our it has to be the base. So AE here is the base, and then K is the perpendicular height. You see, so AE and K. So we have AE here, and then K. For triangle DEC, we can see that EC is the base, and then K would be the perpendicular height. You see. So here can I have a half multiplied by the base times k. We said the base is what again? EC. There we go. This is where actually hints. But here we can fill in what we have to fill in. So fortunately, for this part here, the half can cancel the half, h cancels h. You'll be left with AD over BD. And then once you have written this out and you have simplified, no, it should make this smaller because this is like a division line. So this goes here to that, to that. There we go. So this cancels this cancels that. Then this is what you have. And then it says here, but the area of triangle BED. So the area of triangle DEB is equal to DEC. See, is equal to area of triangle DEC. The reason is triangles between parallel lines, their areas are the same, you see. So if you know that the areas of this triangle and this triangle are the same, it means that if you take the area of triangle ADE and you put it over the area of triangle DEB, it will be the same as the area of triangle ADE over the area of triangle DEC. You see, let's see, let me do it like this here. Area, you see, because look, if these are both equal, it means that this is equal to this, and then this is already equal to that. So the area here is equal to the area there. And then you can say, therefore, GAD over BD is equal to AE over EC because of these two statements here. You see, the area here is equal to this expression, area here is equal to this expression. So you just proved that these two areas here, these ratios here, are equal to each other. So it means these two here have to be equal to each other. So this is the kind of a proof where you don't need to worry about doing it differently. The way it is being done here is the way you always need to do it. So you don't need to worry about having your own way. You can just do it the way it is being done. So let's move on to the next question. Let's see what the next question says here. The next question, okay, more proportionality theorem work, which is fine. So obviously when it comes to things like the proportionality theorem, yeah, your best bet is definitely the Euclidean geometry course on the course website. That is super duper important. So do not miss the opportunity to get the marks that you deserve, you see. So let's see. Let's see here. So with what they're saying here, they said in the diagram, ABCD is a parallelogram. Yes, we are seeing parallel. The diagonals of A, B, C, D intersect at M. So the diagonals meet here. Then they said here, if F, they said F is a point on AD. F, there we go. And then they said such that the ratio between AF and FD is equal to 4 to 3. So let's just say 4x here, 3x here. Then it says E is a point on AM. E is a point on AM, right? Yes. And then it says such that EF is parallel to BD. That's fine. And then it says here FC, where's FC? This line over here, and MD, they intersect with G. Okay, fine. It seems like an okay question. Well, when you deal with questions that look like this, always look for cases in your sketch that have an image that resembles something like this. Anytime where you have parallel lines, pay attention to that spot. You see, like here, this is parallel to that. You see, so this here is somewhat useful. So don't overlook this here. And then also we have a section here where you see these parallel lines here. You can also view them in this triangle here, like that, you see. That seems like it's going to be useful to us. So let's get on. So all this being said, they said calculate with reasons the ratio of EM over AM. Okay, so EM over AM is not going to be difficult at all, because firstly, AE over AE, no, this is F, AF over FD, it's the ratio 4 to 3. So if this is 4x and 3x, this side also the ratio is going to be 4 to 3. We should not forget that. So what we can say is, we know that EM over AM, right? EM over AM is going to be equal to FD over AD. You see the reason there, you can just say proportionality theorem. You see, because what you see happening here, you see EM over AM will be equal to FD over AD. So that's fine. Let us move forward. So this being said, now you can say, therefore, FD over AD is equal to FD, right? It's 3. You can say 3x if you want. Over AD, the whole thing there would be like 7x. You see, of which this can just cancel out. So you can say here, therefore, EM over AM is equal to 3 over 7. That's going to give you 3 marks. Not bad at all. So we can move on from here. If these are the kinds of questions where you still struggle and you're not sure what we did, well, here you can obviously maybe even rewind and see how we answered the question. However, it's also one of those things where this is actually one of the easy questions. So if you think that this is like the part that is maybe a bit difficult, then yeah, you need to learn your basics so that these questions are not as difficult as you may think. But let's move on to the next one. The next one says 9.2.2 says calculate CM over ME. CM, right, over what? ME. So you see now the purple triangle is coming into effect. But before we worry about that, here we said this side we can label this as like 4y. This we can label it as like 3y. Yeah. How many marks is this question? 3. Okay. You get the ratio CM over ME. So if you're gonna get the ratio CM over ME, right? The one thing we can do is we have to obviously make use of the information that they have given us. We have only been given one ratio, and that ratio is what should give us everything. This is where your laws of parallelograms come into effect, because diagonals of a parallelogram are equal to each other. So AM, the distance of AM is equal to MC. because diagonals of a parallelogram are equal. You see, so let's write that down. AM over MC, they're equal. You see, those are things that will help you. Let's just say AM is equal to CM. The reason is diagonals of a parallelogram. So you see, it's not only the theorems that will bail you out, it's your laws of these different shapes that will help you. So if this is 4y and 3y, you could look at this as like 7y, you see. So if you're going to get the ratio CM over ME, it's not difficult at all. CM over ME is going to be 7 over 3. You see, so here you can say, therefore, CM over ME is equal to 7 over 3. That's why this is just a 3-mark question, because the bulk of your answer comes from you knowing this. And then this will be more of a conclusion. And the 7 is, you see, there's 3 here, there's 4 and 3 there. So that's going to give you all your marks. You don't have to worry too much about these kinds of questions. So moving on from here, we need to, let's see here, CM and AM over ME. Yeah, so moving on from here, right? What do we need to do? We have to work out 9.2.3. 9.2.3 says we should calculate the area of, we should calculate this ratio, the area of one triangle over the area of another triangle. So remember, areas of triangles, half base times height is always going to help. So we need to be able to clearly see what is the base, what is the height. So let's look at triangle FDC. Triangle FD and C. Yeah, we have to be strategic about what we look at as the base and what we look at as the height, because anything can be the base and the height. Anything can be the base or the you can choose any side to be the base, but you have to be careful what you make your perpendicular height. So for triangle A, let's look at the two triangles and see where they can at least have something in common. So when you work these two, when you work something like this, try to find some common ground between these two triangles. And we see they look like they both have DC as a length. So let's see. FDC, right, is this triangle here. FDC. There you go. And then you have, where's that other triangle? BDC. So BDC is this one. BDC. So these are triangles that are in between parallel lines. And these are not necessarily inside a triangle like this here, you see. These are equal because they are triangles in between parallel lines inside a portion of your sketch where you have like a big triangle there. This setup here is not necessarily exactly like that, but we do have these two triangles sharing the same base, you see. Let's see here. So with that being said, the way you're gonna work out the area here, let's see, we have to be careful what we make our perpendicular height, because fortunately the base, we have the same value, but the perpendicular height is going to be the determining factor. Let's see the information that we had here. We know that this is the ratio here. I don't know if I don't think, yeah, the ratios are important because here we know the ratio is like 4:3, right? So let's label that the way we did, 4:3. Remember, putting x's there is to show us it's not a distance, it's just a ratio. So here the ratio is 4:3, right? So if this is 4x and 3x, this whole side is going to be 7x. So it looks as though we can use, what can we use? Well, if this is the base, the perpendicular height, yeah, the perpendicular height has to be something. Oh, let's see if we can. Yeah, let's think about this nicely. So let's look at triangle FDC. If this is the what you may call the base, right? The perpendicular height would need to be this line here, but we don't have information for that. So let's leave it. And then if you were to make F okay, if you were to make FD your base, then this would need to be your perpendicular height. And it looks like this is a distance that can work as a perpendicular height for both triangles. Because if this is the perpendicular height for the green triangle, this can be the perpendicular height for the pink triangle, of which they are the same length, you see. Because with the green triangle, if you have it like this, don't get confused, because look, if this green triangle was like that, it's easy for you to see that this is the perpendicular height. You see, it's the same idea here. We're just looking at it almost like it's upside down, you see. This is the base, so your perpendicular height has to come from here, going perpendicular to the base. So what we know is this distance here, this height is the same as that height. That's what we know. So if you're going to give an area for FBC, you can say it's a half. The base is FD. So I guess making this the base was not going to be useful. Let's just get on. So we have there a half. The base is FD. The perpendicular height, you can label it H. And then here you're going to have B. Where is B? B a half, right? A half. Your base here would need to be BC, right? BC. And then the height here is H also. So this is where you start. But remember with question 9 here, they want you to give the ratio, you see. So from here, you know that at least this cancels this cancels this. So you only have FD over BC. So with FD over BC, you can at least see here, this you can label it as 3x. And then you see here BC, you can label it as 7x. And then this x cancels that x. You see. So therefore, your area, therefore, let me just rewrite this. Therefore, area, bro, you put therefore there and then you write somewhere else. Therefore, area of triangle what? Let's see here. Yeah, here. Therefore, area of triangle FGC over the area of triangle BDC. This is going to be equal to 3 over 7. This was quite an interesting question. I think it's a up to standard kind of a question. So that's that for question number 9. This is the basics of your proportionality theorem. You need to be able to work with ratios. You need to be able to work with your sketches. You need to think outside the box. So that's that. Let's move on to the next question.
It says here 2 circles. Okay, 2 circles have a common tangent. So obviously, this is the kind of a question where you definitely want to read the installment. But you want to look at that on the scale. So 2 circles, yes, they have this common tangent. And I think it would be a good idea to highlight that tangent. And also, the moment we read a statement like this one, we would already be thinking of things like, the 10-chord theorem and tangents and radiuses meter angle 90 degrees. Already here, I'm seeing the 10-chord theorem for the small circle. And then, fortunately, it's the same thing for the big one. You see, this here is equal to that angle because this angle there is subtended by the chord SR, and then this angle here is subtended by the chord WR. So all these three angles are equal. That's going to be very useful. And then they said here, W is any point on the small circle. So that's interesting. So W is a point on the small circle. I think they meant a point on the small circle. Yeah. Because normally with these kinds of questions, yeah, it's kind of not normal for them to be able to move around a point because it will just mess up the whole. So here it says the lines RWS meets the large circle at S. Okay, so we don't want to be naive here. They're telling us this line meets the large circle there. Fine, and then they said here the chord STQ. Where's STQ? STQ is a tangent to the small circle HG. Okay, that's very important because we have another tangent. So obviously having another tangent means we have tan cot theta yet again, and we will use it when we need it because it looks like this angle here is going to be equal to that one because of things like tan cot theta. Or rather, let's actually put, so for this tan cot theorem here, right? We know that this one has to go with that one, and I mean this big angle here goes with that one because of the tan cot theorem. I don't want to put too much information on this case because some of it you may not actually need it. So here with the tan cot theorem, oh yeah, we have to make it color coded. So fortunately here, the tan cot theorem, this angle here is equal to that one because of the tan cot theorem. But yeah, let's just carry on and see what we then have. It also then says here, which is a tangent where T is the point of contact for RGP. Where's RGP? There's R here, GP. But RGP is gone. They said we should let this angle here be equal to X. So this is our angle for X, which is R4, and then R2 is equal to Y. Okay. So what's important about this question is they didn't tell us that anything here is a radius or diameter. So we shouldn't assume. Okay, all this being said, this is, I think, in this kind of question, if you see that your sketch is a bit, if it is a lot of information like this, when you're done reading your description, the one thing I can safely say is try and go through these arguments and try and see if you can, add more information for yourself because that's usually helpful. Diameters, we said we don't have radiuses, we don't have C's for second chords, and we do have a second chord, of which, yeah, remembering that something is a cyclic chord is a huge advantage. And maybe put it in another color. We have a cyclic chord here, right? So if we have a cyclic chord, we need to think of laws that deal with cyclic chords. So fortunately here we have lines in the cyclic chord that crisscross each other. So we have angles in the same segment that are going to be equal to each other. And then this line is extended. This is definitely on purpose because this automatically gives us an exterior angle here that is equal to the opposite interior. So not get overwhelmed with information. Just put what you know you might maybe forget or what you know is definitely super. Not like every random information. Like for example here, we already know that we have angles in the same segment that are equal, angles in the same segment that are equal. There's like 4 steps, but you don't have to like mark all of them because it's not something to really forget that easily. P, parallel lines, we don't have any parallel lines, but just because of what we have just gotten here, you see this is equal to that one because they are both equal to this because of the angle theta. If these two angles are equal, automatically we know these are parallel. So let's just keep that in mind. Change this question about that. Let's just move on to the first question. So we don't waste time. then from now it says complete the table on the diagram. Okay, so if you complete this table, they've given a statement for made reason. First statement says T3 is equal to X. What's the reason? Where is T3? T3 is here, they said it is equal to X, yes. So those are equal because of the 10th of here. Yeah, T3 is equal to X and code P1. And then P1 is equal to X. Wait, P1 is here, also 10 here. 10 code P1. And then we have WT parallel to S with WT. Oh, why is this parallel? Okay, corresponding angles. See? Because we have these two angles equal to each other, so those have to be parallel. Corresponding angles are equal. So we are seeing corresponding angles that are equal to each other. So these have to be parallel. Let's see here. S1, why is it equal to Y? Where is S1? S1 is over here. Yeah, you see? This is what we're saying. These are angles in the same segment. So they have to be equal to each other. That's why here in the file, angles in the same segment. Angles in the same segment. T2 is equal to Y. T2 here, Y is equal to Y. Zigzag here. Alternate angles. So this is also equal to Y. Plane of information. Alternating angles. There we go. So with all this being said, very easy. 5 marks here. We could have easily gotten 10, but they gave us all the moving on. Whoa, we have to prove this expression as multiplication. Okay, so another. So these kinds of questions, we obviously need our sketch. Now, the way this sketch is given out, yeah, I usually, with these kinds of questions, it's out of two, so it's not a very difficult question. So I don't think we'll have a hard time figuring out what to do here, because it's a matter of just keeping in mind the lines that they're talking about. So here they're talking about RT, or rather, this is an expression that clearly comes from the proportional theorem. So one thing that is obviously going to be important is this sketch, because this is the one that has the parallel line, and it's the one that has the line. So we have this here, this there, this there, like that. See? There we go. So this is obviously going to be useful, because if you look at the lines that they're talking about, prove that this expression is for this expression. You need to know where to start. So starting, we can start at this point. We can see that they're talking about the line R. So the R is there. And then they're talking about WR. So WR is the one here. And then they're talking about RP. RP is the big one there. And they're talking about RS. RS is the big one there. So obviously that's just clearly the proportionality theorem, if you think of it. You know? And we can even write out the proportionality theorem based on how we were reading these. You see, we wrote RT first, and then we got WR, and then we saw RT, and then we saw RS. So this is, we can easily just say something like RT over RW, or we can call it WR if you want, just like here. We know that that's going to be equal to RE over RS. Your reason there is just going to be proportionality theorem. But obviously, if you then multiply by WR on both sides, you're going to then have the answer that they want to have. Well, yeah, there we go. So these would cancel each other, and then you have RT equal to PR, or let's start WR as ADA, the coming out the RS. Yeah, so be careful of when they use the letters R and P because they're very look-alike. It's easy to write P when you want to write R, and then sometimes you get confused in your calculation. So just look out for that. Here it says identify with reasons another true angle equal to y. So I think the best we can do is to copy our sketch. We need another two angles equal to y. So the focus is on y. We know two angles equal to y already. It's these ones here that we got, but they want two more in addition to that. And fortunately, this sketch has so much information. Now, this is why, this is a parallel. Okay, so we have identified that already. So we did say this is a cyclic quad. And what else? What else? It's just it's just a 4 mark question. So it's like 2 marks per statement and reason, 2 marks per statement. We did speak of the tangent theorem. Yes. Remember, this is a tangent as we know. So we have a tangent here and a chord, you see, in this small circle. So this angle is equal to that one. Because the tangent theorem needs you to look for an angle that is subtended by the chord that meets the tangent. This chord here meets this tangent. So this angle that is formed is equal to the angle that is subtended by the chord in tangent. So we can say that the R3 is equal to y plus this tangent theorem. Then this section chord, and obviously here we can now even look for an angle that is equal to R3, which is obviously this one because they are angles in the same section. R3 goes all the way to SP, and then this angle here also goes, it's subtended by SP to big. So here we can say Q1 equal to I3, which is equal to Y. The reason is angles in the same segment. Nothing crazy, nothing major. So, with all this being said, we need to move on to 10.4. Prove that Q3 is equal to W2. Where is Q3 and W? We have so much information. So Q3 is here, W2 is there. Okay, so this question, I can see why it's just 2 marks because the longer you do this kind of questions, things add up faster. Because the logic tells us we need to find something equal to Q3 and something equal to W2 individually. So if you think that these are parallel, as we say, so we can already see that these two are going to be equal because they are corresponding angles. And then from what we said in the beginning, right in the beginning here, we said that this is an exterior angle and this is an opposite interior angle of a cyclic quadrilateral, and we know those are equal. So you see, this is equal to that because of one reason. Exterior angle of a cyclic quad is equal to the opposite interior one. And this is also equal to this angle because they're corresponding angles. So since they're equal to the same angle, these have to be equal to each other. And that's how we go about it. You see, W2 is equal to PSR. W2 is equal to PSR. And then the reason corresponding angle. Q3 is equal to PSR also. Therefore, you see here I wrote R by PSR here. So since they're both equal to the same thing right here, give it a reason, right? The reason is this exterior angle from outside the quad. Exterior angle of cyclic quad. There you go. And then here, what's the next thing now? Exterior angle of cyclic quad. Then we can now say therefore W2 is equal to So that's fine. And then here it says prove that RTS. Okay. I have another case here that whoa, this is interesting. Prove that RTS is similar to RTP. So let's see what those angles are. RGS, we prove that it is similar to, let's triangle that. Do this here. There we go. The triangle that they're talking about is RQP. So there's RQP here, RQP. There we go. Yeah, they share the same line here. So if you're gonna prove that those two are similar, fortunately it's a straightforward question. Let me just adjust this thing here and need to adjust this also. Is it fine? No, better. So it's 3 more questions, so it's not difficult. Fortunately, these are the kinds of questions that almost give you what you should do as they're asking. So if you're going to prove two triangles similar here, they'll be telling you that prove that R is R. So meaning you should prove that the angle R here is equal to the angle R for the other one, which I believe we have done. Yes, we have done that already. It's proven. So that settles that. And then we need to then prove that angle Q is equal to T. So Q for the big one is equal to T for the small one. And then maybe color code it in a way that is a bit unique as opposed to using a color code already there. So we need to prove that this one is equal to this one. Doing that, this one seems like it's gonna be the crazy looking one or the crazy hard one, so we might forfeit doing that one. We can maybe find something else, and then that one can be like the third set of angles that are equal. We can use the law that says two angles that add up 180 if we have at least shown that two sets of angles are equal. So what I'm trying to say is finding that S is here, right? And P is this is easy to show that they're equal. This is easy to show that they're equal. So whenever you prove the similarities, you can always choose the two pairs of angles that are easy to work with. And then the third ones, you automatically say that they're equal because all three angles are so let's do that. We're gonna start, we can start with whichever one. S2 equal to P2. The reason is the angles in the same segment. R3 is equal to R2, proven. And then here we can say therefore this angle T here, which is STR, STR is equal to PQR. PQR, right? The reason for that is just sum of interior angles of the triangle, sum of interior angles of the triangle. So let's see what else to do here. 10.55. Okay, 10.68. Let's prove that this is. Wait, we're not done. As long as you've proven that all three angles are equal, all three pairs, you can say therefore triangle RGS is similar to triangle RQ. The reason will just be angle. There we go. That's the way we like it. And then 10.68 let's prove that WR over RQ is RS squared over RQ squared. So it's just a 3-mark question, so this should not be difficult. The other thing is a lot of these lines, yeah, we can get them from the two triangles we're working with. The only unique item here looks like it's WR, but we have an expression that had WR here that they asked us to do just now. Is it this one? So I might as well take this also. The reason why I'm taking this is because it's a 3-mark question and it looks like it has something we use in a previous question. And the other thing is these lines that are squared, it means we will eventually have an expression where these values are being multiplied by themselves. So because we've just proven similarity, and because this question is asking you to, because this question is starting with the word hence, this is a huge indicator, or the main indicator, that you need to take what we have just done and you need to make use of it. Answer this question. 100% of the time, whenever they start a question with hence, it means use what you've just discovered to answer what they're asking. So with all proportionality questions, as long as you've proven that triangles are similar, you're able to write out proportionality expression, which say, for example, RT over RQ, RT over RQ, there we go, this is equal to TS over 2T, TS over 2T, which is also equal to RS, RT, RS, RT, there we go. So all things considered, you would now want to look for two pairs that can at least have these lines here. So in this expression and in this expression already has everything that we need in this. So this is fine. This is not a problem. This, however, these are three of them. Okay, you have to give a reason why you wrote this. The reason is the proportionality of similar triangles. That's why you wrote this. So here you can only use two at a time. And we need to pick out two that at least have lines that are in this expression. So in this expression, okay, there's no RT, fine, but there's RQ. GS, there's no GS in there. PQP, there's no QP in there. RS, there's definitely RS in there. RP, there's definitely RP in there. So it looks like using this and this is our best bet. So let's isolate those. RP here, RS. So the one thing you want to realize with all math is that it all eventually falls on algebra. You know, whatever you will do, you just need specific knowledge first, and then it's just an algebraic expression that you end up with. So fortunately, this expression does not have RT, and it looks like that's the only thing that these two both have, which we can almost eliminate, or rather, here we already have RT as the subject of the formula. It looks like if we can make RT the subject of the formula here, we can then just make these equations equal to each other, because they'll both be equal to RT, or rather RT will be the subject formula for both. So here we can multiply by RQ there also, and then we're going to have RT on its own equal to RS over RP. So if you want, or which we can do, we can label this equation number 1, label this equation number 2. And then we can just say equation number 1 is equal to equation number 2. Wait, did I do something? I did. I forgot. There we go. So here we can just write RT is equal to RT. Therefore, for the first version of RT here that we worked out, which is just WR and RT over RS is equal to RS times RQ over RP. So this being said, we have this times the top, yeah, and this times that. So with how they want it, we can have WR on the left. So this times this will give us WR times PR squared. This times this will give us RS squared. And then looks like they want us to have RQ at the bottom and RP at the bottom. So that's not difficult because here we can just divide by RQ on both sides first. It will give us WR times this over RQ. Here the RQ will just cancel out. So you'll have RS squared on its own, right? Here, this whole thing of changing colors is that way. So from here now you can then also then divide by RP squared divided by RP squared. And then you can have RS squared over RP squared. These cancel out, then you're gonna have WR over RQ. There you go. That's your answer. So that seems fine, nothing crazy. This paper was not bad at all. I think it was definitely doable. Now, everything that we've touched on within this paper, you want to remember that there's an online course for each and every topic on our course website. So, on our course website, that is where you will be able to learn in detail how to answer any kind of math question that you may be required to answer. So, for example, if I can give you an idea of what the course website looks like, there we go, courses of writing brains, etc. So if you click on the link in the description, this is the current homepage. You can see that this package gives you access to absolutely every course, every online course. There's 10 of the maths topics, and then the other 7 is just additional material, including something like the NBT course, the NBT MAT course. You can sign up to, wait, this is not the, let me refresh this, because I believe this is, I think what I was seeing is what it looked like in December, but when it doesn't say, let me refresh this page here. Why is my network? There we go. So this is the current homepage. We have things like Saturday classes. These are in-person classes. So this is the package you were seeing, the all access pass gives access to everything. And then you have things like NBT course. This is a once-off fee. You'll have access to the NBT course for a full year. And then these are just other packages that have different combinations. So, for example, this is a combination that has these topics, 5 of these topics, and 5 courses there. This is a combination that has every course on the website, meaning each and every topic. So each and every topic, as you can see, there's things like Euclidean geometry, functions and graphs, trigonometry, all these individual courses here, of which you can choose to sign up for a monthly subscription, which you can cancel, or you can just pay once off, and then you have access for 365 days, which is a full year. In addition to all this, if you want, you could just sign up for Zoom sessions. You can have one Zoom session for the full year, one Zoom session every week. And this package also includes online courses. You can either sign up monthly or you can sign up once off for the full year. And this also, as mentioned, includes the entire course catalog. If you do want to sign up for like one topic at a time, you can do that. For example, something like Euclidean geometry, you can just sign up for that on its own. It's going to be something like 99 Rand. And all the other individual topics also, you can do that. Okay. Functions and graphs, etc. We do have a math study guide that we recommend. This is just another package, depending on if you want to only look at 2 topics. And obviously, we have all the details that you need on the FAQ. If you wanna have a EFT, if you need to ask questions, you can always do so. You can either contact me on WhatsApp, you can contact me on Instagram, you can make contact whichever way you can. If you do want to email me, you can do so by emailing BY at rightyoungbrains.co.za. So let's just put that here. BY right young brains.co.za. There we go. That's that. So good. Cheers. If you need to ask questions, you can just hit me up on Instagram. If these videos are helpful, which I believe they are, don't forget to subscribe. Don't forget to plug your friends. And I'll catch you in the next video.